Welcome to this course. In the dynamic world of IT, the ability to quickly and effectively diagnose and resolve issues is invaluable. This course will elevate your troubleshooting abilities so that you can become a skilled problem solver across various technical environments. You can rest assured that this course is crafted by experts in the field, combining their subject matter expertise and industry experience. It provides you with both theoretical understanding and practical skills, along with the ability to solve real-world problems. These are essential for thriving in an entry-level IT support position. Throughout this comprehensive course, you will learn to apply a systematic approach to diagnosing and resolving issues across different hardware and software environments. Through a mix of videos, readings, activities, and quizzes, you will develop troubleshooting skills that will help you contribute to maintaining and enhancing an organization's system reliability and performance. You will also gain proficiency in using diagnostic tools and techniques which are vital for IT professionals to manage complex systems and networks. Now let's explore the content to make sure you're ready to start the course. You will be introduced to the following topics: troubleshooting methodologies, troubleshooting operating systems, and advanced troubleshooting techniques. To begin with, you will learn the basics of troubleshooting to help you develop effective troubleshooting practices. In other words, you will learn about common hardware issues and the essential problem-solving approaches and strategies you should employ to resolve them. For example, applying logic and elimination methods and clearly documenting and communicating the solution you come up with. Troubleshooting operating systems is a considerable part of a career in IT. To help you develop the relevant skills and knowledge, you will explore the tools and techniques necessary for handling software issues across various operating systems. These include Windows, Linux, and Mac OS. You'll also learn to tackle system-related and cross-platform challenges. You will then move on to advanced troubleshooting techniques, a section of the course that is designed to enhance your skills with strategies for resolving more complex and uncommon technical issues. This part of the course covers cutting-edge diagnostic tools and utilities, offering deeper insights into networking scenarios and specialized troubleshooting. The course culminates in a final capstone project where you will apply your accumulated skills and knowledge to a real-world scenario, demonstrating your ability to synthesize and implement effective solutions. You'll be provided with multiple diagnostic outputs and will be tasked with identifying the issue and recommending a solution. You'll also be required to document and communicate your troubleshooting process and outcome. This project is a cornerstone of the learning process, preparing you for practical IT problem solving in professional environments. You will also complete one final graded assessment that tests your knowledge of the whole course. This course forms part of your preparation for the MS900 Microsoft 365 Fundamentals exam. Taking the MS900 exam will set you up for a career as an IT professional. The great thing is you don't need a background in IT-related fields to take this course. It is for anyone who has an affinity for technology and an interest in IT. In summary, this course provides you with a complete introduction to troubleshooting diagnostics and techniques, ensuring that you have the necessary knowledge and skills to make good decisions and implement robust solutions in diverse IT environments. Additionally, it also prepares you for the MS900 exam. We've reached the end of this course introduction, so it's time to prepare yourself to become an adept troubleshooter, ready to tackle technical challenges with confidence and expertise. Imagine this scenario. You're the IT person at your office, and suddenly everything grinds to a halt because of a mysterious software glitch. In this situation, knowing how to troubleshoot is a game changer. Troubleshooting at its core is a systematic process aimed at identifying, diagnosing, and resolving problems within hardware and software systems. It's not just about quick fixes, it's more about understanding the intricacies of systems, predicting potential problems, and implementing solutions that ensure reliability and efficiency. This video serves as an introduction to the essence of troubleshooting, its significance in the tech industry, and how it serves as a cornerstone for IT professionals. The significance of troubleshooting in today's technologically driven society cannot be overstated, as it forms the cornerstone of ensuring operational continuity and reliability in various sectors. In an age where technology is deeply integrated into both the professional and personal realms, disruptions can cause significant financial losses, reduce productivity, and lower user satisfaction. Therefore, swiftly and adeptly handling these disruptions is crucial. Troubleshooting empowers IT professionals to go beyond just treating the superficial symptoms of issues, urging them to address the underlying causes of disruptions. This systematic process makes long-term fixes instead of temporary patches possible, addressing the core of the problem. Furthermore, interventions should not only be immediate and practical, but also sustainable, thereby enhancing the resilience and reliability of technological systems. Troubleshooting is a methodical process. It begins with identification of the problem through the observation of symptoms and the gathering of information. This step is critical as it sets the direction for all subsequent actions. Once the problem is identified, the next step involves diagnosing and analyzing the issue, which means pinpointing the exact cause. This phase often requires a good understanding of the system's workings and might involve the use of diagnostic tools or software to analyze data and test hypotheses. After the diagnosis is clear, the resolution phase can begin. This involves implementing a solution to address the identified cause of the problem. Solutions can range from simple fixes like rebooting a system to more complex interventions such as rewriting portions of code or replacing faulty hardware components. After the resolution is applied, it is crucial to verify that the problem has been effectively solved and that the system is functioning as expected. While troubleshooting is often viewed as a reactive measure, something that's only done in response to an issue, its true value lies in its proactive capabilities. By understanding the common causes of failures and identifying patterns in system behavior, IT professionals can anticipate problems before they occur and implement preventative measures to mitigate potential impacts. This proactive approach to troubleshooting reduces downtime and contributes to the reliability and efficiency of systems. Therefore, in the tech industry, where innovation and uptime are very important, troubleshooting skills are indispensable. They enable professionals to maintain the integrity of systems, ensure the seamless delivery of services, and ultimately contribute to the satisfaction of users and the success of businesses. Effective troubleshooting can be the difference between a minor interruption and a significant operational setback, making it a critical skill for anyone working with technology. Developing troubleshooting skills requires a blend of theoretical knowledge and practical experience. It involves a deep understanding of the systems one is working with and the ability to think critically and creatively to solve problems. The most effective way to enhance these skills is through hands-on experience, dealing with real-world problems, experimenting with different solutions, and learning from both successes and failures. In summary, troubleshooting is more than a set of techniques to fix problems. It's a critical thinking skill that is essential in the modern tech landscape. It requires a systematic approach and a proactive mindset to not only solve problems but also prevent them. As technology continues to advance and integrate into every aspect of our lives, troubleshooting skills will only increase in value, making them a critical competency for IT professionals. You've probably had the experience of being frustrated with a product and reaching out for support. But what if, instead of an impersonal response, you receive thoughtful, empathetic assistance that truly solves your problem? This is the essence of happiness engineering. This approach leverages effective communication, empathy, and advanced problem-solving skills to elevate the standard of support from mere transactional exchanges to meaningful, positive experiences. This video explores how these elements contribute to happiness engineering, the adverse effects of inadequate support, and the common pitfalls in IT support. The importance of happiness engineering cannot be overstated, especially when considering the consequences of poor IT support. Negative support experiences can lead to frustration on the part of employees and a loss of confidence in the support they are offered. High-quality IT support is characterized by understanding, patience, and effective resolution. However, achieving excellence in IT support is not without its challenges. One of the common pitfalls in support, especially from a troubleshooting perspective, is the lack of effective communication. Miscommunication can lead to misunderstandings, exacerbating employee frustrations, and leading to missed opportunities for resolution. Another significant challenge is the lack of empathy. IT support professionals who fail to empathize with employees' situations may come across as cold or indifferent, diminishing trust and satisfaction. Additionally, insufficient problem-solving skills can hinder the ability to provide quick and effective solutions, leaving employees dissatisfied and likely to seek alternatives. Addressing these issues requires a strategic approach that includes training support teams in the principles of happiness engineering. Effective communication is the cornerstone of this strategy. Training programs should focus on enhancing listening skills, clear and concise communication, and the ability to convey complex solutions in an understandable manner. Empathy training is equally important as it equips IT professionals with the skills needed to connect with employees emotionally, fostering a sense of understanding and care. Furthermore, equipping support teams with robust problem-solving skills ensures they can navigate complex issues efficiently and offer solutions that meet employees' needs. In practice, happiness engineering involves a series of strategic actions tailored to elevate the IT support experience. For instance, personalizing interactions by using the employee's name, acknowledging their previous interactions with IT support, and tailoring solutions to their specific needs can significantly enhance satisfaction. Additionally, following up after resolving their issues demonstrates ongoing care and commitment, reinforcing a positive perception of the support team. Leveraging technology can also play a pivotal role in happiness engineering. There are tools like chatbots and AI-powered analytics that can provide support teams with valuable insights into employee preferences and behavior, enabling more personalized and efficient service. However, it's crucial to balance technological solutions with a human touch, ensuring that employees always feel valued and understood. Happiness engineering represents a paradigm shift in IT support, emphasizing the creation of positive, satisfying experiences. At its core, it is about crafting interactions that solve problems and deliver joy and satisfaction. By focusing on effective communication, empathy, and problem solving, support teams can avoid the pitfalls of poor support and build a strong, positive relationship with employees. The benefits of happiness engineering in IT support extend beyond immediate user satisfaction. They contribute to long-term operational success, increased employee loyalty, and therefore a competitive advantage in the industry. Happiness engineering is revolutionizing the way businesses approach IT support by focusing on effective communication, empathy, and robust problem-solving skills. Embracing happiness engineering is essential for any company aiming to thrive, turning every support interaction into an opportunity for growth and satisfaction. Imagine sitting down to start your day, only to be greeted by a sluggish computer that slows your productivity. Frustrating, right? This video will help you troubleshoot this common problem, identifying why a computer is lagging and offering a structured method to diagnose and fix the issue. By learning these techniques, you'll not only reduce immediate annoyances, but also improve a computer's overall performance. Get ready to discover practical steps to keep a system running smoothly. The first step in troubleshooting is to describe the problem accurately. A computer slowing down can manifest in various ways. Applications take longer to open, files take longer to load, the system takes longer to boot up, or overall responsiveness decreases. Identifying when and how the slowdown occurs can provide initial clues about the underlying cause. The second part of describing the problem is to identify potential causes. Several factors can cause a computer to slow down, including hardware limitations, software conflicts, malware infections, and system settings. The most common causes include limited RAM. If the computer does not have enough RAM to handle running applications, it will start using the hard drive as virtual memory, significantly slowing down performance. A nearly full hard drive can cause the computer to slow down because the operating system doesn't have enough free space to work effectively. There is also the possibility that malware can consume system resources running in the background without your knowledge. Or outdated software can cause compatibility issues, and having too many applications running simultaneously can overwhelm the system's resources. Another potential cause is that numerous processes running in the background can drain the computer's performance, and over time, files on the hard drive can become fragmented, making it harder for the computer to read them efficiently. Lastly, excessive heat can cause the computer to throttle down performance to protect hardware components. The second step of troubleshooting is analysis. Here, there are several things that you can investigate that might be a possible cause. You should check the hardware specifications to ensure that the computer meets the requirements for its intended use. Running modern software on older hardware can lead to performance issues. If this is a root cause, the solution would be to upgrade the RAM or switch from a hard disk drive to a solid-state drive, which can significantly improve speed. Secondly, freeing up disk space can improve performance. If this is the core issue, you should uninstall unused programs, delete temporary files, and move large files or documents to an external drive or cloud storage. Thirdly, you should scan for malware and viruses. Use a reputable antivirus program to scan the system. If the scan shows malware, removal tools can help eliminate any infections that could be slowing down the computer. The fourth option is to check if any programs automatically run at startup and consume resources. To remedy this problem, you should use the operating system's task manager to disable unnecessary startup programs. Fifth, you should ensure that the operating system, applications, and drivers are up to date. Software developers are always aiming to improve the performance and security of their products by regularly releasing updates, so you should keep things up to date. You should also close applications and processes that are not in use. Tools like the Task Manager can help you identify resource-intensive processes that you can shut down to boost performance. You also have the option to defragment the hard drive if the computer has one. Defragmenting the disk can improve performance by reorganizing files to be accessed more efficiently. The last option is to ensure the computer's cooling system is working correctly. Cleaning out dust from vents and fans can help prevent overheating and maintain performance. Let's turn our attention to a scenario. Consider Juan, who notices that his 4-year-old laptop has become significantly slower, especially when opening applications and during startup. He contacts IT support for help. Following the troubleshooting steps, the IT professional first checks the system's RAM usage and finds it nearly maxed out. She decides to upgrade the RAM from 4 GB to 8 GB. She also notices that the hard drive is 95% full, prompting her to delete unnecessary files and transfer large media files to an external drive, freeing up over 150 GB. After scanning for malware and finding a couple of minor infections, she uses his antivirus software to clean them up. Lastly, she disables several unnecessary startup programs and updates all software, including the operating system. After completing these steps, Juan's laptop performance significantly improves. The system boots up faster, applications open promptly, and the overall responsiveness of his laptop enhances his productivity and user experience. A slow computer can stem from various causes, from hardware limitations to software issues. Most performance issues can be resolved by methodically troubleshooting, starting with simple solutions and moving to more complex ones. Regular maintenance, such as updating software, managing startup programs, and monitoring system resources, can prevent many slowdowns and ensure the computer remains fast and efficient. Ever feel like you're playing whack-a-mole with IT problems? Fix one issue and another pops up? That's where root cause analysis, or RCA, can come in handy. It's all about digging deep to find and fix the actual cause of problems so they don't derail productivity, consume valuable resources, or keep coming back. Let's consider a scenario in which a company experiences intermittent internet connectivity issues that impact its operations. The IT team decides to undertake an RCA process to address this problem in collaboration with the Internet Service Provider, or ISP. The first step involves clearly articulating the issue at hand. For an intermittent internet connection, this means recognizing and defining the service inconsistency as a significant problem affecting operations and user experience. Following this, the IT team and their ISP have to gather data. This involves documenting the occurrence of connectivity issues, pinpointing specific times, locations, and any observable patterns or triggers that precede the disruptions. Such data gathering might include network logs, user reports, and any system alerts. With the collected data, the next step involves a deep dive into identifying potential causes. In this scenario, the problem is observed mostly during peak usage times, prompting an investigation into capacity constraints or network management practices. Analytical tools like the 5 Whys, a fishbone diagram, or a Pareto chart can be useful during this step. Let's explore these 3 tools before moving on to the next RCA step. The 5 Whys involves asking why 5 times, or as many times as needed, to drill down to the root cause of a problem. Starting with the problem statement, each answer forms the basis of the next question. This straightforward technique helps to quickly identify the cause of a problem by peeling away the layers of symptoms. Next, a fishbone diagram helps identify the cause and effect relationships underlying a particular problem. It visualizes the main causes of a problem and breaks them down into finer detail. These causes are usually categorized into major groups, which can vary but commonly include people, processes, policies, and environment. Lastly is a Pareto chart, a graphical tool that represents data in a bar graph where the values are displayed in descending order of frequency or size. It is based on the Pareto principle, which is also known as the 80-20 rule. It states that a small number of causes often lead to a large portion of the problem. Here is an example of a chart an IT team used to analyze software bugs reported over 3 months to identify the most frequent causes and prioritize them for resolution. Ultimately, a Pareto chart helps IT professionals identify the most significant factors contributing to a problem and focus efforts on the changes that will have the greatest impact. The analysis in the scenario, performed using one or more of these tools, should lead to the next step of RCA, which is identifying the primary cause or causes of the problem. In the scenario, the IT team finds that the issue stems from inadequate network capacity or inefficient bandwidth allocation to handle high traffic volumes. Armed with an understanding of the root cause, the ISP can now formulate and implement a strategy to address the issue. This may involve infrastructure upgrades to increase network capacity and refining network management protocols to ensure optimal performance during peak demand periods. The final step in the RCA process is to continuously monitor network performance after solutions have been implemented. This ensures that the corrective actions have effectively resolved the problem and helps identify any recurring or new issues early on. By methodically completing these steps, the RCA process has helped the IT team address the immediate issue of intermittent internet connectivity, which contributes to the overall reliability and efficiency of network services. The scenario demonstrates that RCA can be very beneficial to IT teams. Let's quickly recap those benefits. By addressing the root cause, RCA helps prevent the recurrence of similar issues. It also saves time and resources in the long run by eliminating the need for temporary fixes. And it leads to quality improvements in processes and products by identifying and correcting underlying issues. In summary, root cause analysis is a vital method for resolving complex problems. Its structured approach, illustrated by the network connectivity scenario, allows for in-depth problem analysis and prioritization. Adopting RCA promotes a culture of continuous improvement, which is crucial for operational reliability and service efficiency in the business world. When facing a complex IT issue, it may seem overwhelming at first glance. In such situations, the ideal framework can provide a structured and methodical path to resolution. This scenario-based approach can help IT professionals identify the problem, define the goal, explore possible strategies, act on the best strategy, and look back at the situation and learn from it. This systematic approach facilitates the resolution of immediate issues and contributes to a culture of continuous improvement and learning. Let's examine the 5 stages. The process begins with a comprehensive examination of the issue at hand. This crucial first step involves delving deep into the situation to distinguish between simple symptoms and the root cause of the problem. Gathering and analyzing relevant data is essential at this stage, laying the foundation for all subsequent actions. For instance, in an IT context, this could mean identifying a network outage. With a clear understanding of the problem, the next step is to articulate what a successful resolution looks like. Setting clear, measurable, and achievable objectives provides a sense of direction and serves as a benchmark against which the effectiveness of solutions can be measured. This phase requires considering the expectations of all stakeholders involved and ensuring that the defined goals are aligned with broader objectives. It sets the stage for strategic decision-making, guiding the problem-solving process toward outcomes that offer the most significant benefit. In the IT example where a network outage was identified as the problem, the goal could be to restore network access within an hour. Armed with a detailed problem definition and clear objectives, the focus shifts to generating and assessing potential solutions. This exploration phase is characterized by creativity and critical thinking, encouraging the consideration of a wide array of strategies. Each potential solution is weighed for its pros and cons, taking into account factors such as feasibility, resources required, and potential impact. This process ensures a thorough evaluation of options, facilitating informed decision-making in selecting the strategy most likely to achieve the defined goals. The ability to troubleshoot effectively in this way can prevent a minor interruption from turning into a significant operational setback, making it a critical skill for anyone working with technology. Returning to the IT problem of addressing a network outage, this troubleshooting process could involve exploring solutions like router resets or internet service provider checks. Next, selecting the most viable strategy marks the transition from planning to action. Implementing the chosen solution requires meticulous planning, resource allocation, and timeline management. This phase often involves coordinating efforts across teams or departments, ensuring that all actions are aligned with the overall strategy. Putting theoretical solutions into practice requires effective execution, which means being flexible and quick to handle any problems that come up during implementation. In the example, taking action might involve resetting the router. The final phase of the ideal framework is both reflective and forward-looking. After implementing the solution, it's important to review the outcomes, comparing them against the initially defined goals to determine the effectiveness of the approach. This reflective process assesses the immediate impact of the solution and identifies lessons learned, contributing to a deeper understanding of the problem-solving process. It is an opportunity to refine strategies, make adjustments as necessary, and consolidate the knowledge gained, thereby enhancing the capacity for problem-solving in future endeavors. In the network outage example, this phase of the ideal framework would involve reviewing the cause of the outage and the effectiveness of the response to prevent future issues. In summary, applying the ideal framework equips individuals and organizations with a robust problem-solving methodology. It emphasizes the importance of clarity, strategic thinking, and adaptability, qualities essential for navigating the complexities of the modern world. Through diligent application of each phase, the ideal framework can help resolve immediate issues and strengthen the overall capacity for future problem solving. The quest for solutions in both their professional and personal lives often leads people down a complex path of problem solving and decision making. Among the many strategies available, logic and elimination methods stand out because they are so effective in helping people navigate the maze of possibilities. These methods, rooted in the principles of rational thought and systematic exclusion, provide a robust framework for identifying the most viable solutions to problems. This video explores deductive and inductive reasoning, trial and error, and the process of elimination to help you grasp their applications and benefits. Logic, a foundational element of effective problem solving, can be segmented into two primary types: deductive and inductive reasoning. When you use deductive reasoning, you start with a general statement or hypothesis, and then you examine the possibilities to reach a logical conclusion. It operates on the principle of top-down logic, where the conclusion must logically follow from the given premise. For example, if all birds have wings and a sparrow is a bird, then it logically follows that a sparrow has wings. This method is particularly effective in situations where the initial premise is an accepted truth, allowing for a high degree of certainty in the conclusions reached. Let's turn our attention to an IT troubleshooting example. A company's web server is down following a recent software update. The goal is to restore a server functionality as quickly as possible. Using deductive reasoning, the IT team start with the general statement that the server was working fine before the update, so the update is likely the cause. Thus, troubleshooting efforts should focus on issues introduced by the update. Inductive reasoning, on the other hand, works from the bottom up. It begins with specific observations and measures and seeks to derive general principles from these. Although the conclusions drawn from inductive reasoning are somewhat uncertain, this method is invaluable for generating hypotheses and theories, especially in fields such as science and research, where experimentation and observation are key. Sticking with the web server example, using inductive reasoning, the IT team remembers observing in previous incidents that configuration errors often occurred after updates. Therefore, they deduce that the current issue might be a misconfiguration introduced by the update. The next method, using trial and error, might seem unsophisticated, but it's a powerful tool in the problem-solving arsenal. It involves attempting multiple solutions with the expectation that some will fail, but also with the hope that one will eventually succeed. This method shines in scenarios where the range of possible solutions is known, but the correct one is not immediately obvious. It's a hands-on approach that encourages experimentation and learning from mistakes, fostering a deeper understanding of the problem at hand. Returning to the web server example, using trial and error, the IT team first tried to revert the software update. If that doesn't resolve the issue, they systematically reconfigure the server settings, checking each change to see if it restores functionality. Closely related to trial and error is the process of elimination, a strategy that systematically discards options that are proven incorrect, narrowing the field of possibilities until the correct solution emerges. It is particularly effective in scenarios with a finite set of possible solutions, such as diagnostic processes in medicine or troubleshooting in engineering. By eliminating what does not work, the process focuses efforts on the most promising solution, enhancing efficiency and saving valuable time and resources. In the web server example, the IT team would use the process of elimination by reviewing server logs to identify and rule out specific errors or issues. By eliminating potential problems one by one, such as firewall settings or application configurations, they can pinpoint that a specific misconfiguration caused the downtime. Employing logic and elimination methods in problem solving offers many benefits. These methods promote clarity and precision, breaking down complex problems into manageable parts and focusing on logical steps toward a solution. They encourage a structured approach to decision-making, reducing the influence of biases and emotions and leading to more objective and rational outcomes. What's more, the use of logic and elimination fosters critical thinking and analytical skills. It challenges individuals to scrutinize their assumptions, to question the validity of their premises, and to rigorously test their conclusions. This not only leads to better problem solving in the immediate context, but also cultivates a mindset that is invaluable for facing future challenges. In conclusion, the effective application of logic and elimination methods transforms the daunting task of problem solving into a structured and manageable process. By harnessing the power of deductive and inductive reasoning, alongside trial and error and the process of elimination, individuals can confidently navigate through the complexities of decision-making. These methods not only facilitate the identification of viable solutions, but also promote a culture of critical thinking and continuous learning. Exploring the inner workings of a computer system reveals a complex array of hardware components, each performing its unique function to ensure the machine's smooth operation. From the central processing unit or CPU acting as the brain of the computer to the power supply unit or PSU providing the necessary energy, understanding these components and the potential issues they can have is crucial for IT professionals. In this video, you will explore the assortment of common hardware components and their potential issues, as well as briefly examine how issues can be prevented. First is the motherboard, the backbone of a computer. It offers a platform for communication between various components, such as the CPU, storage devices, and more. It also houses the basic input-output system, or BIOS, which initializes the hardware during startup. Motherboards can suffer from physical damage, short circuits, or component failures. Compatibility issues can also arise, especially with newer CPUs or RAM requiring a BIOS update or even a replacement. Second is random access memory, or RAM. It temporarily stores data for quick access by the CPU, facilitating the smooth operation of applications and the operating system. Faulty RAM can lead to system instability, crashes, and data corruption. Compatibility and speed mismatches between different RAM sticks can also cause issues, as can running out of RAM, which forces the system to rely on slower storage as a substitute. Third is the CPU, which executes instructions from programs, performing calculations and operations that drive the computer's tasks. Overheating is a common problem, often due to poor cooling solutions or excessive dust buildup. Thermal paste degradation over time can also reduce its effectiveness in transferring heat. This paste is a substance applied between the CPU and the heat sink in a computer. Its primary function is to improve the thermal conductivity between these components. Other than heating issues, CPUs can also be bottlenecked by other components, limiting performance if, for example, the RAM is too slow or insufficient. Fourth are hard disk drives and solid-state drives, which provide long-term data storage. Due to their lack of moving parts, SSDs are faster and more reliable, but they tend to be more expensive per gigabyte than HDDs. HDDs are susceptible to physical damage and wear over time, potentially leading to data loss. SSDs, while more durable, have a limited number of write cycles before cells begin to wear out, which can also result in data loss or drive failure. Fifth is the power supply unit, which converts power from the wall outlet into usable low-voltage DC power for the computer's components. A failing PSU can lead to power instability, causing random reboots or shutdowns. An underpowered PSU cannot supply enough power, leading to performance issues or damage to components. Over time, PSUs can degrade, providing less power than they originally could, which might necessitate an upgrade, especially when adding more power-hungry components. Sixth is the graphics processing unit. While integrated GPUs are part of the CPU and execute everyday tasks, dedicated GPUs are crucial for gaming, video editing, and other graphics-intensive tasks. Similar to CPUs, overheating can reduce performance and lifespan. Driver issues can also cause instability, crashes, or poor performance. Compatibility with the motherboard and PSU for power requirements is essential for smooth operation. Next are cooling systems, including fans and heat sinks that dissipate heat from components to prevent overheating. Dust accumulation can impede fan performance, and mechanical failure can result in fans stopping altogether. Inadequate cooling can lead to thermal throttling, where components reduce their performance to stay within safe temperature ranges. Last are keyboards, mice, monitors, and other peripherals that interface with the computer to provide input and output capabilities. Physical damage or wear and tear can cause these devices to fail. Driver or compatibility issues, especially with newer operating systems or hardware, can also prevent them from functioning correctly. To mitigate potential problems with hardware components, regular maintenance and monitoring are key. Keeping systems clean, ensuring adequate cooling, updating drivers and BIOS, and using components that match performance and power requirements can prevent many common problems. Additionally, using diagnostic tools to monitor system health and identify failing components before they cause more significant issues can save time and money. In summary, while hardware components in a computer system work together to perform complex tasks, they are not without vulnerabilities. Awareness of these potential issues and taking proactive measures to prevent them can greatly enhance a computer system's longevity and performance. A well-maintained system is a reliable foundation for any task, whether for personal use or professional applications. Imagine you're in the middle of an important project when suddenly your computer crashes. It might be a hardware failure, but there's no need to worry. This video is here to help. It explores common reasons why hardware fails and demonstrates practical steps to diagnose and fix these issues. Whether it's a cracked screen, an overheating CPU, or a mysterious error code, you'll learn how to get a computer back up and running in no time. Let's first examine some common causes of hardware failure. First up is physical damage. This type of hardware failure is often the result of direct impact or environmental conditions that exceed what the equipment is designed to withstand. External forces can cause immediate and visible damage to components like hard drives, which are sensitive to shock, or screens that can easily crack. Next is wear and tear. Regular operation over long periods causes the hardware to deteriorate. Components such as fans are particularly vulnerable, and their failure can escalate into more severe issues like system overheating. This natural degradation is the primary reason why maintenance and periodic replacement of parts are essential for hardware longevity. Another cause of hardware failure is power surges. Fluctuations in power supply can lead to overvoltage that exceeds the tolerance of computer components. Power surges can originate from various sources, including lightning strikes, faulty wiring, or issues with the utility company's equipment. Surge protectors and uninterruptible power supplies, or UPS, are critical in safeguarding sensitive electronics against such unpredictable events. A very common source of problems is overheating. Proper thermal management is crucial for preventing hardware failures. Overheating can be caused by accumulations of dust blocking air pathways, fan failure, or inadequate cooling systems. Prolonged exposure to high temperatures can damage electronic components irreversibly, leading to system crashes and reduced hardware lifespan. Lastly, manufacturing defects can cause hardware issues. Sometimes defects occur during the manufacturing process of components like microprocessors or memory chips. These defects may not be apparent immediately and can cause failures under normal operating conditions. Identifying such defects usually requires diagnostic tests that can detect irregular behavior or premature failure of components. There are several steps you can take to diagnose hardware failures. The first line of defense in diagnosing hardware issues is visual inspection. A thorough check for any physical anomalies such as cracks, broken connectors, or signs of electrical burn on the circuit boards can help quickly pinpoint where a problem might lie. Visual checks are straightforward and can prevent the need for more invasive testing if the issue is apparent, such as water damage or visible burns. Modern operating systems also provide detailed error messages and keep system logs that track system operations and failures. The blue screen of death in Windows, for example, displays stop codes that can be used to identify specific issues. Tools like Event Viewer in Windows or the Console app for macOS provide logs that can be inspected to find the time and details of hardware failures. This aids in diagnostics and determines whether software or hardware is at fault. Something else you can make use of to diagnose hardware failure are beep codes and a power-on self-test or POST. During a power-on self-test, systems perform checks before the operating system loads, verifying that essential hardware components like RAM, CPU, and graphics cards are functioning correctly. Failure in these tests results in beep codes, a series of audible beeps that correspond to specific hardware issues. These codes are particularly useful for troubleshooting problems that prevent the computer from booting. You interpret these beeps using the motherboard manual. Thirdly, diagnostic software tools are invaluable for deeper inspection of a system's health. Tools such as memtest86 can test memory stability, while others like HDD scan can check hard drives for bad sectors or failure risks. These tools provide comprehensive diagnostics and are often used by technicians to ensure component functionality. Another crucial diagnostic tool is thermal monitoring. Overheating can cause significant hardware failures. Monitoring software and BIOS or UEFI interfaces can provide real-time temperature data for critical components like CPUs, GPUs, and chipsets. If temperatures exceed normal operating ranges, it can signal poor ventilation, failing cooling systems, or environmental factors that need correction to prevent damage. A highly effective method for diagnosing hardware issues involves swapping out suspected faulty components with ones that are known to function correctly. This technique can confirm the hardware component causing the issue, whether it's RAM sticks, GPUs, or even power supplies, and is a direct way to isolate the faulty part. For more complex issues, professional diagnostic tools used by IT departments can diagnose problems that basic checks cannot. These tools often include sophisticated software and hardware interfaces that test various components under different conditions to pinpoint failures accurately. Properly diagnosing hardware failures requires a systematic approach that begins with simple, non-invasive checks and progresses to more detailed diagnostics. By understanding the common causes of hardware failures and employing a range of diagnostic tools, IT professionals can identify the issues affecting systems and take appropriate measures to repair or replace faulty components. Printers are essential tools in both office and home settings, but they can often present frustrating challenges. Problems ranging from paper jams to connectivity issues can disrupt workflow and cause unnecessary stress. Understanding how to troubleshoot these problems efficiently can save time and restore functionality to this critical piece of equipment. This video explores 5 common printer issues and offers advice on how to fix them. Firstly, one of the most common printer issues is a paper jam. This occurs when paper becomes stuck in the printer and can be caused by several factors, including the use of incorrect paper size, misaligned paper trays, or even humidity. To fix a paper jam, first, turn off the printer and gently remove any stuck paper. Check for any visible paper fragments that might still be inside, and ensure the paper tray is properly aligned and not overloaded. Second, low ink or toner warnings can be frustrating, especially if they occur when the cartridges still seem to have plenty of ink left. First, you should check the printer's ink levels to confirm they are indeed low. Remove the ink cartridge and gently shake it to redistribute the ink or toner evenly, then reinstall it. If the printer still shows a low ink warning, it may be time to replace the cartridge. Third, poor print quality can manifest as faded prints, streaks, or smudges. This issue often stems from either low ink levels or clogged print heads. Start by checking and replacing any low ink cartridges. For clogged print heads, most printers have a self-cleaning function that can be activated through the printer's menu. If this doesn't resolve the issue, manually cleaning the print heads with a damp cloth may be necessary. Fourth are connectivity issues. Printers can sometimes fail to communicate with the computer, smartphone, or network. If you encounter connectivity problems, verify that the printer is properly connected to your device or network. Check all physical connections like USB or Ethernet cables. If the office is using wireless connections, ensure the printer is connected to the right network and the signal is strong. Sometimes just restarting both the printer and the computer can resolve connectivity issues. Fifth are driver problems. Outdated or corrupted printer drivers can lead to a variety of issues, including the printer not being recognized by the computer or malfunctioning during operation. To resolve driver issues, visit the printer manufacturer's website and download the latest drivers for the relevant printer model. You should install the drivers according to the manufacturer's instructions. If basic troubleshooting does not resolve the problem, it may be necessary to delve deeper. For example, persistent paper jam issues might require examining the printer's internal components, such as the fuser and rollers. Resetting the printer's network settings can also help in cases of severe connectivity problems. For persistent complex problems, the best course of action may be to contact the manufacturer's customer support or consult a specialist. Regular maintenance is very important to ensure that a printer remains operational. You should keep the printer clean from dust and debris, which can accumulate and cause hardware problems. Also, make sure to use the right type of paper and store it in a dry, flat place to avoid paper jams and print quality issues. One frequently overlooked aspect of printer maintenance is the importance of software and firmware updates. These updates not only provide new features and compatibility with newer operating systems, but are also crucial for security purposes. Printers, like any other internet-connected device, can be vulnerable to security breaches. Updates are often released by manufacturers to patch security vulnerabilities and fix bugs that may affect printer performance and reliability. IT professionals should regularly check for firmware updates via the printer's interface or on the manufacturer's website. Installing these updates can prevent many problems before they occur, enhance functionality, and ensure that the printer operates efficiently with other devices and software applications. While printers are invaluable tools, they are not immune to problems. By understanding common issues and how to troubleshoot them, IT professionals can ensure minimal disruption and maintain printer functionality. Remember that most printer problems are solvable with a bit of patience and the right approach. When in doubt, refer to the printer's manual or seek help from a specialist to keep your printer running smoothly and efficiently. Congratulations on completing this module. You've explored key aspects of troubleshooting methodologies, including the concept and importance of troubleshooting, various problem-solving strategies and models, and common hardware issues that may arise in computer systems. After completing the module, you should now be able to explain the troubleshooting process and its benefits, discuss different problem-solving strategies and models, and identify and troubleshoot common hardware issues. Let's recap what you've covered. In the first part of the module, you learned about the significance of troubleshooting in maintaining and repairing technology systems, emphasizing its role in minimizing downtime, improving system reliability, and enhancing user satisfaction. This section set the foundation for understanding troubleshooting not just as a reactive measure, but as a proactive skill set essential for IT professionals. You then explored the 4 fundamental steps of the troubleshooting process: identification, analysis, action, and verification. This structured approach ensures effective and efficient problem solving, providing a framework that can be applied across various types of technical issues. The concept of happiness engineering was also introduced, highlighting the importance of empathetic and effective communication skills in IT support. Next, you explored best practices and tips for troubleshooting, such as asking the right questions, gathering information, documenting the process, verifying results, and following up with users. You then walked through a troubleshooting scenario for slow computers, learning how to apply these practices in a real-world situation. Additionally, you covered common troubleshooting mistakes and how to avoid them, ensuring you can sidestep potential pitfalls and improve your problem-solving effectiveness. In the second part of the module, your focus shifted to problem-solving strategies. You learned about root cause analysis and its benefits, along with the steps and tools involved such as the 5 whys, the fishbone diagram, and the Pareto chart. You also explored the Kepner-Trago method and the ideal framework, both systematic approaches to problem solving and decision making. These strategies help you identify the underlying causes of problems and develop effective solutions. You were introduced to using SWOT analysis and a decision matrix, tools that help evaluate and compare possible solutions to a problem. By applying logic and elimination methods, you learned how to narrow down and test possible solutions using deductive and inductive reasoning, trial and error, and process of elimination. The importance of documentation and clear communication was emphasized, highlighting best practices for recording each step of the troubleshooting process and sharing findings and solutions with team members and stakeholders. In the third part of the module, you focused on hardware issues. You explored hardware components, their functions, and potential issues they can cause. Benchmarking was introduced as a crucial technique for evaluating the performance of key computer components like processors, SSDs, and GPUs. You also analyzed hardware failures and their causes such as physical damage, wear and tear, power surges, and overheating. Various methods for diagnosing hardware failures were demonstrated, including visual inspection, error messages, beep codes, and diagnostic software. Additionally, you learned about performance, audio, and video issues and their solutions, along with best practices for upgrading and repairing computer components. With a focus on both theoretical understanding and practical application, you are now equipped to troubleshoot and resolve common issues effectively by applying structured problem-solving strategies. As you prepare to test your knowledge in the module quiz, remember that the resources in this module are always available should you need to review any concepts to reinforce your understanding. Best of luck as you move forward to the quiz. Under ideal circumstances, a computer is an effective and efficient machine, one that relies on hardware and software components to keep everything running smoothly. But just like any machine, things can go wrong, and when they do, it can disrupt work environments. This video explores the world of software components, their functions, and their associated issues to help you expand your IT troubleshooting toolkit. Let's start with the most fundamental software component of a computer, the operating system, or OS. The OS is the foundational software layer that manages hardware and software resources and provides common services for programs. It serves as the crucial interface between physical hardware and the end user's application software. It has several core functions. Let's examine them. First is resource management. The OS optimally allocates hardware resources such as CPU time, memory space, and input-output channels to various software programs, ensuring efficient system performance. Second is file system management. Operating systems organize data into files and directories, managing storage space on hard drives and other media. This includes tasks like reading, writing, creating, and deleting files. Third is process management. The OS handles process creation, scheduling, and termination, as well as process states like running and waiting. Operating systems coordinate these processes to ensure smooth execution and a fair distribution of resources like CPU time and memory so that each process gets an appropriate share. This prevents any single process from monopolizing resources and ensures that no process is starved of resources. Fourth is security and access control. Operating systems enforce security protocols, manage user permissions, and protect data integrity against unauthorized access or alterations. And fifth is the user interface, or UI. The OS provides a user interface, such as a command line or graphical user interface, also known as GUI, that allows users to interact with the system and run applications. With all these functions come a number of potential issues. Crashes and freezes can occur due to bugs in the OS or conflicts with hardware drivers. OS components can be exploited by malicious software if not regularly updated. Additionally, new versions of an OS might not support older hardware or applications, leading to outdated functionality. And over time, operating systems may suffer from decreased performance due to disk fragmentation, the accumulation of unused files, or background processes consuming system resources. Next, let's discuss applications. Applications, also known as software programs, are sets of instructions that direct a computer to perform specific tasks. These tasks range from simple functions like text editing to complex operations such as data analysis or network management. Applications are built on programming languages and use the operating system as an intermediary to access necessary hardware resources such as the CPU, memory, and network interfaces. Software programs depend on the OS for three reasons. The OS abstracts the hardware details, providing applications with a standard interface to access hardware resources. And as you just learned, it also manages the allocation and scheduling of CPU time, memory, and storage, balancing the needs of different applications. Furthermore, it provides application programming interfaces, or APIs, for applications to send and receive data over networks, manage files, and communicate with other services. Of course, these functions come with their own set of possible problems. Errors in application code can cause unexpected behavior or data loss. Poorly optimized applications may consume excessive CPU or memory, leading to slowdowns. And applications may not function properly on all operating systems or with all hardware configurations. An overview of software components would not be complete without a discussion of utility software. Utility software encompasses a variety of programs designed to assist in managing, maintaining, and optimizing computer systems. These tools serve specific functions that enhance the performance, security, and usability of computers. Possible problems with utility software include the following. Some utilities might interfere with the normal operation of other software, particularly if they require deep system access. For example, antivirus programs might mistakenly classify legitimate software as malicious, leading to the deletion or quarantine of important files. And utilities, especially those running in the background like real-time antivirus software, can significantly reduce system performance. Lastly, we have drivers, essential software components that make communication between the OS and hardware devices possible. Each driver is specifically designed to communicate with a particular device or class of devices, translating general OS commands into device-specific actions that hardware can execute. Potential driver issues include driver conflicts. Multiple drivers trying to access the same device can lead to system instability or hardware malfunctions. Outdated drivers may not work properly with updated OS versions or newer hardware, reducing functionality or performance. And incorrectly installed drivers can cause numerous issues, including device non-recognition, crashes, or system errors. In summary, software components are integral to the functioning of modern computer systems, but come with their own set of challenges. Errors, crashes, and bugs are common issues that can stem from these components. Understanding these components and their potential issues is crucial for troubleshooting and ensuring system stability and security. Log analysis is a crucial technique in software troubleshooting, particularly in environments that are dependent on Microsoft technologies. Logs such as event logs, application logs, and system logs offer a deep dive into the workings of software applications and operating systems. They provide essential clues that can help diagnose and resolve a wide range of issues. This video guides you through the process of handling logs in a Microsoft environment. It will cover how to access, view, filter, and interpret logs. Let's start with how to access and view logs. In Microsoft environments, the most common type of logs are Windows event logs, which can be accessed using the Event Viewer. This is a built-in Windows tool that organizes logs into categories like application, security, and system. To access these logs, you have to navigate to the Event Viewer in Windows. This can be done by pressing the Windows button and R at the same time. Then type eventvwr.msc in the entry field and press Enter. In Event Viewer, logs are systematically organized, making it easier to find the specific logs you need. For example, to access application-specific logs, you select Windows Logs in the Event Viewer window and then Application. Next, let's discuss filtering logs. This function is especially important in a Microsoft environment due to the volume of logs that Windows systems can generate. The Event Viewer allows for custom views where you can create filters to display only the relevant logs. For example, to create a filter for all critical errors in the system log, you right-click on Custom Views in the left-hand side pane of the Event Viewer window. From the drop-down menu that appears, you select Create Custom View. In the window that opens, select the criteria for your view. For instance, you can select the time frame of the logs you want to view, then select the event level, in this case critical, and you then select the event log, which is system in this example. This functionality simplifies the troubleshooting process by allowing you to focus on the logs that are most likely to contain relevant information about the issues you are experiencing. Once you've accessed the relevant logs, the next step is to interpret them. Windows event logs provide detailed information, including the event ID, which is critical for identifying specific errors and warnings. For instance, an event ID of 1000 generally indicates an application crash. This ID, along with the error description and faulting module path provided in the details pane, helps in pinpointing the cause of the crash. Here is an example of a common log entry in the Windows Event Viewer. This entry provides a comprehensive overview of what happened, including which application crashed and which module caused the crash. The exception code 0xC0000005 indicates an access violation, which suggests that the program tried to read or write to a protected memory address. Now let's discuss another crucial log source in Microsoft environments, the Internet Information Services or IIS log, which records all HTTP server communication. Analyzing these logs can provide insights into HTTP errors, user activity, and other web server operations for web applications running on IIS. The Internet Information Services is the web server software from Microsoft that hosts web applications and services on Windows servers. To access IIS logs, open File Explorer by pressing the Windows and E keys at the same time, and navigate to the IIS logs directory by entering this file path in the address bar of File Explorer. These logs are not part of Windows event logs and need to be analyzed separately using tools like Log Parser. Log Parser provides universal query access to text-based data such as log files. For example, this is a log parser query to find 500 internal server errors, which are HTTP status codes that indicate that the server encountered an unexpected condition that prevented it from fulfilling the request. This command helps identify which pages are throwing server errors, which is a vital step in troubleshooting web applications. For advanced log analysis, modern systems often use tools like Microsoft's System Center Operations Manager or SCOM, Splunk, and others. These are essential for managing the complexities of large-scale or cloud-based infrastructures. SCOM provides comprehensive monitoring across servers and applications, delivering alerts, visual data, and detailed reports to help system administrators manage IT environments proactively. Similarly, Splunk offers extensive log management and analysis capabilities, enabling you to search, monitor, and analyze big data with real-time processing. This is crucial for generating actionable insights through graphs, reports, and dashboards. These advanced tools are critical for maintaining operational efficiency and quickly addressing system issues. Logs are an indispensable resource for troubleshooting software issues in Microsoft environments. By effectively accessing, viewing, filtering, and interpreting these logs, IT professionals can significantly enhance their troubleshooting efficiency. Few things are as daunting as being presented with a black screen when trying to boot up a computer. Troubleshooting issues related to BIOS, boot sequences, and firmware can be intimidating, but understanding the fundamental concepts and steps can simplify the process. This video addresses common problems such as boot failures, BIOS corruption, CMOS battery issues, and firmware problems. It also outlines methods to address these issues. You may already know about BIOS, firmware, and operating systems, but let's do a quick refresher. The basic input-output system, commonly referred to as BIOS, initializes hardware during the boot process and provides essential runtime services. Firmware, on the other hand, refers to the specialized software permanently installed in hardware. And a computer's operating system is the core layer of software that coordinates computer hardware and software resources, offering essential services for applications. Now let's examine some common BIOS and firmware issues. First is boot failure, which occurs when the computer fails to boot into the operating system due to various reasons. Misconfigured BIOS settings, such as incorrect boot order, can prevent the system from detecting the bootable drive. Faulty hardware, such as malfunctioning hard drives or defective RAM modules, can also disrupt the boot process. Additionally, corrupted boot files on the storage device can make it impossible for the computer to locate the operating system. Addressing boot failure typically involves verifying BIOS settings, checking hardware components, and, if needed, repairing or reinstalling the operating system. Second is BIOS corruption, which renders the system unbootable. A corrupted BIOS typically shows itself through power-on self-test or post errors, or the system continuously rebooting into it. Power surges, failed updates, and malware infections can damage the BIOS firmware. Recovery methods include using backup BIOS features provided by modern motherboards, updating the BIOS from a USB drive, or employing specialized recovery tools to restore the firmware. Third is CMOS battery failure. CMOS stands for complementary metal oxide semiconductor. This battery powers a small memory chip that stores BIOS settings, ensuring they persist even when the computer is powered off. When the battery fails, the BIOS reverts to its default settings, which might be incompatible with the system configuration. This can prevent booting or lead to inaccurate system time. Replacing the CMOS battery is usually a straightforward task, restoring the retention of customized BIOS settings. Fourth are firmware update issues. Updates enhance system performance, fix bugs, and introduce new features. However, incorrect or interrupted updates can destabilize the system or worse, break the device, rendering it unusable. To prevent problems, it is crucial to adhere carefully to the manufacturer's update guidelines and ensure stable power during the update process. If an update fails, recovery often requires manually updating the firmware again or seeking help from a specialist. Now let's turn our attention to the potential steps you can take to pinpoint a BIOS, boot, or firmware problem. Your first step should be to check hardware connections. Loose or faulty connections can cause boot issues. You should ensure all internal cables, cards, and memory modules are securely attached. Next, you can access BIOS settings to troubleshoot. To access the BIOS setup, you should press a specific key during boot. This is commonly Delete, F2, or F10. Doing so allows you to verify or modify settings such as boot order and hardware configurations. If the system is unresponsive or erratic, resetting BIOS to factory defaults can resolve configuration conflicts. This can be done through the BIOS menu or by physically removing the CMOS battery for a few minutes. If you need to bypass issues with the primary drive, you can use the boot menu options, often accessed via F12 or the escape key, to select different devices to boot from. Lastly, for operating systems like Windows, booting into safe mode or using recovery options can help fix issues that prevent normal booting. There are also some advanced troubleshooting techniques you can make use of. If bugs or compatibility issues are suspected, updating the BIOS to the latest version can be beneficial. This typically involves downloading a firmware file from the motherboard manufacturer's website and applying it through an updater utility provided within the BIOS itself. If the computer encounters any hardware issues, it will emit beep codes during the power-on self-test. These beeps can be decoded using the motherboard's manual to identify specific problems. You can also use diagnostic tools. Many motherboard manufacturers provide diagnostic tools that can be run from within the BIOS or from a bootable USB drive. These tools can test hardware components like RAM, CPUs, and storage devices. If you want to avoid BIOS, boot, and firmware problems altogether, it's important to take some preventative measures. You can do the following: regularly update BIOS and firmware to patch known vulnerabilities and bugs, maintain a stable power supply with surge protection to avoid corruption caused by power fluctuations, and back up BIOS settings and critical data regularly to simplify recovery in case of failure. While BIOS, boot, and firmware issues can be intricate and troublesome, a methodical approach to troubleshooting can effectively resolve many common problems. Familiarity with BIOS settings, careful hardware checks, and the prudent use of recovery tools form the cornerstone of effective system maintenance and repair. You may have experienced the following scenario before. You're all set to start your day, ready to tackle that important project, but when you press your computer's power button, nothing happens. Or worse, you see an error message and the system fails to boot. It's frustrating, but don't worry. Troubleshooting boot and startup issues can be straightforward once you understand what's going on under the hood. This video will walk you through the technical aspects of booting processes, common issues that disrupt these processes, practical troubleshooting steps to get a computer up and running again, and some preventative measures you can take to avoid problems altogether. First, let's start with an overview of the boot process and how it works. Upon powering up a computer, the booting process begins, which involves loading the operating system into the system's memory to prepare it for use. Once the computer is powered up and the operating system is loaded, the BIOS or UEFI firmware checks and initializes hardware components. A system will use either UEFI or BIOS, note both, since UEFI is a replacement for BIOS. UEFI stands for Unified Extensible Firmware Interface, and modern systems typically use it due to its enhanced capabilities and support for newer technologies. Once hardware components are initialized, the firmware identifies a boot device, such as a hard drive or SSD, to find a bootloader that will then start the OS. Here are the specific steps that a computer system takes to become operational, from powering on to loading the operating system. First, in the BIOS or UEFI phase, the firmware conducts a power-on self-test to check the hardware's integrity. In UEFI, a pre-boot environment allows users to manage and modify system configurations. Second is the bootloader phase. Once the firmware identifies the boot device, the bootloader takes over, loading the OS kernel into memory. Third is kernel initialization. The kernel sets up the environment for the OS to operate and manages essential services. The kernel acts as a bridge between applications and the physical hardware, ensuring that software instructions are executed efficiently and safely. Now let's examine some common boot and startup issues and their corresponding troubleshooting steps. If critical boot files such as Windows Boot Manager or NT-Loader or Linux's grub are missing, corrupted, or misconfigured, the system may fail to boot correctly because the OS is prevented from starting. Common causes include disk errors, failed updates, and malware attacks. It may be necessary to reinstall or repair the bootloader to address the issue. To repair the bootloader, you can use tools like Windows bootrec and commands like bootrec/fixmbr and bootrec/fixboot. In Linux, grub repair can fix corrupted bootloaders. Next, damaged or incompatible hardware, such as a faulty hard drive, defective RAM, or failing motherboard, can impede the boot process. Testing or replacing the hardware components may be required. You should also check hardware connections to ensure that all cables and components are securely connected. Disconnect and reconnect peripheral devices to rule out external issues. Furthermore, misconfigured boot order or secure boot settings can lead to boot issues. It is essential to ensure that the correct boot device is selected and secure boot is appropriately configured. Accessing BIOS or UEFI settings allows you to check and adjust the boot order, ensuring the primary boot device is correctly selected. If necessary, you should disable secure boot. Incorrect system settings such as invalid registry entries or broken system files can also cause boot failures. You can run diagnostic tools like System File Checker and Check Disk in Windows or FSCK in Linux to check for and repair file system errors. And finally, incompatible or corrupt drivers can prevent the system from booting properly. Updating drivers or booting into safe mode to disable problematic drivers can resolve this. When you boot into safe mode, the system boots with minimal drivers and services, helping you to isolate software issues. If other methods fail, reinstalling the operating system may be required as a last resort. Before proceeding with this process, you should double-check that data backups are available. Now you're familiar with common issues and their fixes, but you can possibly avoid them by implementing some preventative measures related to hardware. For example, regular system maintenance, such as performing routine hardware checks, can identify potential problems before they become critical. Monitoring tools like SMART, which stands for Self-Monitoring Analysis and Reporting Technology, can alert you to potential hard drive failures and enable timely data backups. And updating firmware and hardware drivers can enhance compatibility and improve system stability. On the software side, you should keep the operating system and installed software up to date to prevent security vulnerabilities and compatibility issues. Regularly create system restore points or disk images to provide a fallback option for unexpected failures. Implement redundancy through RAID setups or backup systems for servers and critical systems to mitigate data loss and ensure continuous operations. A RAID setup, or redundant array of independent disks, is a storage technology that integrates multiple physical hard drives into one cohesive system. And finally, using reliable antivirus software and avoiding untrusted downloads can protect the system from malicious software that could corrupt essential boot files or disrupt startup operations. In summary, boot and startup issues can stem from various causes, including hardware failure, corrupted files, and incorrect configurations. By understanding the boot process and using systematic troubleshooting steps, most problems can be diagnosed and resolved efficiently. User account and permission issues can disrupt workflow and compromise security in corporate computing environments. These problems range from forgotten passwords to more complex scenarios like access control misconfigurations. Addressing these challenges requires a combination of technical understanding and the right tools to restore access and ensure systems remain secure. This video explores common problems and their troubleshooting solutions utilizing a variety of tools and techniques. Let's start with the three most common user account problems. One of the most frequent issues is users forgetting their passwords. This can be resolved through password reset tools or administrator resets. Most systems offer a password recovery option where users can reset their passwords via a linked email or mobile number. In corporate environments, administrators can reset the passwords through Active Directory or similar management tools. Secondly, accounts often get locked after several failed login attempts as a security measure against brute force attacks. Administrators can unlock accounts using administrative tools such as the Microsoft Management Console or command line tools like Unlock AD Account in PowerShell for Windows Active Directory environments. Thirdly, access denied errors generally occur due to insufficient permissions to access specific files or applications. Resolving these requires adjusting the permission levels either by the user elevating their access through user account control prompts or by an administrator modifying the user's permissions directly. To effectively troubleshoot and resolve user account and permission issues, several techniques and tools are indispensable. In Windows environments, creating a password reset disk is a proactive measure that allows users to reset their password without administrative intervention. This disk can be created through the control panel under User Accounts. For more technical troubleshooting, the command prompt offers various commands that can be useful. For example, the net user command can display all user accounts on the Windows system, change passwords, and modify account properties. Furthermore, UAC helps prevent unauthorized changes to the operating system by prompting administrative privileges when changes are made. Adjusting UAC settings can solve issues where applications require elevation. However, this should be done cautiously as it may expose the system to security risks. In a domain environment, the Group Policy Editor is a powerful tool that can enforce specific configurations across all user accounts. This tool can manage account lockout policies, password requirements, and user permissions, ensuring compliance and security across the organization. Reviewing security logs is crucial for diagnosing issues related to unauthorized access or unexpected changes in permissions. Tools like Windows Event Viewer provide detailed logs that can help trace the root cause of such issues. Auditing can be configured to log specific events, such as login attempts and resource access, which can then be analyzed to identify and rectify security breaches. Finally, there are various third-party tools available that can help streamline the management of user accounts and permissions. These tools often provide more intuitive interfaces and additional features compared to built-in system tools, which can enhance productivity and security. Ultimately, implementing best practices is key to preventing user account and permission issues. These include regularly updating and auditing user permissions to ensure they align with current roles and responsibilities. Implementing strong password policies and encouraging the use of password managers to help users maintain secure and unique passwords. Educating users on security best practices and the importance of securing their accounts to prevent unauthorized access. Using multi-factor authentication to add an additional layer of security, reducing the risk of compromised passwords leading to unauthorized access. And making use of automated account management systems. Automation enhances the management of user accounts and permissions by increasing efficiency and accuracy. Tools like Microsoft Identity Manager and Okta automate account lifecycle processes, integrate with HR systems for timely updates, and enforce security policies consistently. These solutions reduce human error, ensure secure access, and support security features like periodic password resets and multi-factor authentication. This makes them crucial for maintaining operational efficiency and robust security in IT environments. Troubleshooting user account and permission issues effectively require a mix of technical skills, proactive measures, and the right tools. By understanding common problems and utilizing the techniques and tools discussed, administrators can ensure robust security and functionality in managing user accounts and permissions. Regular audits and adherence to best practices further enhance an organization's security posture, safeguarding against both internal and external threats. Windows activation and authentication issues can pose significant challenges to end users and IT administrators. These problems range from being unable to activate Windows to login difficulties that prevent access to the operating system. This video addresses common Windows activation and authentication problems and their solutions utilizing various tools and techniques. The most common activation problem is when a user is unable to activate Windows at all. This issue can arise due to several reasons, including invalid product keys, hardware changes, and connectivity problems. For a suspected invalid product key, your first step should be to verify the product key. Double-check that the product key being used is correctly entered and has not been previously used on another device. This can be done by checking the key against the original packaging or through the Microsoft account if it was purchased digitally. Significant hardware changes like a motherboard replacement can affect Windows activation. In such cases, Windows may need to be reactivated. This can often be resolved by signing into your Microsoft account and following the prompts to reactivate the device. Occasionally, activation servers may be unreachable due to network issues or server downtimes. This results in failure to activate Windows, generating errors that indicate server unavailability. If you think the root cause is connectivity, you should ensure that the device is connected to the internet and that there are no network issues preventing communication with Microsoft's activation servers. You can also test connectivity by using network diagnostic tools. If none of these troubleshooting steps resolve the problem, you can use the Activation Troubleshooter. This is a Windows tool that can help diagnose and fix common activation issues. To use this tool, navigate to Settings, System, and then Activation. In the Activation settings, you will be able to view the current activation status. If there's a problem, you will see a link that says Troubleshoot. Select this link to launch the Activation Troubleshooter and follow the on-screen instructions to diagnose and resolve any activation issues. If the issue persists despite trying the above steps, contacting Microsoft support can provide additional assistance. They may offer a reissued product key or other solutions based on the specific situation. There are also common authentication issues that can occur. One issue is when a user is unable to log in at all. Users may face issues logging into Windows due to forgotten passwords, corrupted user profiles, or system errors that prevent the login screen from functioning properly. For local accounts, creating a password reset disk beforehand can save a lot of trouble. If a user forgets their password, the reset disk can be used to create a new password without needing administrative intervention. To create a password reset disk, go to the Control panel, navigate to User Accounts, and select Create a Password Reset Disk. For accounts tied to a Microsoft account, users can use online account recovery tools. By visiting the Microsoft account recovery page and following the prompts, users can reset their passwords or unlock their accounts using secondary email addresses or phone numbers. Booting into safe mode and using the command prompt can also help troubleshoot login issues. For instance, if the user profile is corrupted, commands like netuser can be used to create a new user account or reset passwords. Another issue is that after multiple failed login attempts, user accounts can become locked as a security measure. This requires intervention to unlock the account. In a domain environment, administrators can use the Microsoft Management Console to unlock accounts. To do so, they can open the Run dialog box by pressing the Windows and R keys simultaneously and typing mmc.exe. Then they can navigate to Active Directory Users and Computers, find the user account, and clear the account lockout status. Several third-party tools are also available that can assist with password recovery and account unlocking. Tools like Offcrack can help recover passwords by analyzing password hashes, though they should be used with caution and within legal boundaries. In corporate environments, password policies might enforce regular changes, leading to situations where users cannot log in because their password has expired. Password expiration and account lockout policies can be managed using group policy. Administrators can configure these policies to ensure they align with security requirements while minimizing user inconvenience. To do so, they need to open the Run dialog box and type gpedit.msc. They need to navigate to Computer Configuration, then to Windows Settings, followed by Security Settings, and finally to Account Policies. In summary, addressing Windows activation and authentication issues requires a detailed understanding of both the common problems and the tools available for troubleshooting. By following the steps outlined for each specific issue, users and administrators can resolve these challenges efficiently, ensuring continuous and secure access to their systems. Operating systems are the backbone of computer functionality, managing everything from the software a computer runs to the way we interact with our devices. Let's examine three popular operating systems: Windows, Mac OS, and Linux, and see how they stack up in terms of user interface, file systems, security, compatibility, and performance. First up is the user interface, a crucial feature as it directly affects the user experience. Windows, developed by Microsoft, features the well-known Start menu and taskbar. Its UI is designed to be intuitive and user-friendly, making it accessible for users of all skill levels. The latest version, Windows 11, has introduced a centered Start menu and a more streamlined modern look. Mac OS, designed by Apple, is known for its sleek and polished interface. The dock, Finder, and Mission Control are key elements that enhance user navigation and multitasking. Furthermore, the consistency and integration with other Apple products and services, such as iCloud and Continuity, provide a seamless experience for users within the Apple ecosystem. Linux, an open-source operating system, offers a variety of desktop environments such as GNOME, KDE Plasma, and XFCE. Each environment provides a different user experience, allowing for extensive customization. GNOME, for instance, offers a clean and modern interface with a focus on simplicity and productivity, while KDE Plasma provides a more traditional desktop experience with a high degree of configurability. Second is the file system, a vital component that manages how data is stored and retrieved. Windows primarily uses the new technology file system, which supports large files, file permissions, and encryption. NTFS is known for its robustness and reliability, making it suitable for both personal and enterprise use. On the other hand, Mac OS uses the Apple file system introduced in Mac OS High Sierra. APFS is optimized for flash and solid-state drives, offering improved performance, space efficiency, and data integrity. It supports features like snapshots, which allow users to create a read-only copy of the file system at a specific point in time. This is useful for backups and data recovery. Meanwhile, Linux supports various file systems, including the fourth extended file system, XFS, and BTRFS. ext4 is the most commonly used, offering excellent performance and reliability. BTRFS, on the other hand, provides advanced features such as snapshotting and self-healing, making it ideal for systems that require high data integrity. Thirdly, security is a central concern for any operating system. Windows has made significant strides in recent years with features like Windows Defender, BitLocker, and Secure Boot. Despite these advancements, Windows remains a prime target for malware and cyber attacks due to its widespread use. Therefore, regular updates and patches are crucial to maintain security. Mac OS benefits from its Unix-based foundation, which inherently provides strong security features. The system employs sandboxing, which restricts applications' ability to interact with each other and the core system. Gatekeeper and Xprotect are built-in security technologies that protect against malware and untrusted applications. Additionally, macOS receives regular updates that include security patches and enhancements. Linux also has a good reputation when it comes to security and stability. Its open-source nature allows for constant scrutiny by the community, leading to rapid identification and resolution of vulnerabilities. Linux's security model, which includes user permissions and the principle of least privilege, adds an additional layer of protection. Tools like Security Enhanced Linux further enhance security by enforcing mandatory access controls. Next, another essential aspect to consider is compatibility with software and hardware. Windows boasts the broadest compatibility, supporting a vast range of software applications and hardware devices. This extensive support is a significant reason for its dominance in the personal computer market. Windows also offers compatibility modes to run older software versions, which is beneficial for enterprise environments. In comparison, Mac OS is designed to work seamlessly with Apple hardware, providing a tightly integrated and optimized experience. However, this integration comes at the cost of limited hardware compatibility compared to Windows and Linux. Software availability is generally excellent, especially for creative applications, but users may encounter limitations with certain niche or enterprise software that is predominantly Windows-based. Linux, while highly versatile, can sometimes face compatibility challenges, particularly with proprietary software and hardware drivers. However, many open-source alternatives are available, and major software vendors are increasingly offering Linux support. Linux's flexibility allows it to run on a wide array of hardware, from powerful servers to low-resource devices. Last is performance. Windows offers robust performance across a range of hardware configurations, and enhancements in Windows 11 aim to optimize resource management and responsiveness. Mac OS is optimized for performance on Apple hardware, particularly with the advent of Apple silicon chips like the M1 and M2. These chips offer significant performance and power efficiency improvements, enhancing the overall responsiveness and capability of Mac OS. Finally, Linux is highly regarded for its performance and efficiency. Its modular nature allows users to tailor the operating system to their specific needs, removing unnecessary components to reduce overhead. This makes Linux particularly well-suited for servers and high-performance computing environments. Windows, macOS, and Linux each offer unique features catering to different needs. Windows is user-friendly and highly compatible and suitable for general and enterprise use. macOS provides a polished, integrated experience for Apple users. And Linux excels in customization, security, and performance, and is thus favored by developers and IT professionals. Understanding the strengths and weaknesses of these three operating systems is key to making informed decisions based on the specific requirements of the organization you work for. Ensuring the seamless operation of applications across various operating systems is a recurring challenge in organizations, especially for software development companies. Cross-platform software, by definition, is designed to operate on multiple operating systems without significant modifications. Teams have to work tirelessly to develop software that functions correctly on Windows, macOS, and Linux. This video addresses the basics of cross-platform software and file management through a scenario to help you grasp the technical challenges software teams face. Let's set the scene before delving into the details. Jamila runs a software development team, and their main challenges are not just coding, but also efficiently managing associated files. These files need to be accessible and functional, regardless of the operating system. One afternoon, Jamila receives an urgent call from the testing team. They reported that the application they are developing works perfectly on Windows but crashes on macOS. This issue emphasizes the primary challenge of cross-platform software, ensuring consistent performance across different environments. Let's explore some of the technical challenges that could be causing the problem and what Jamila and her team can do to resolve it. First, each operating system has unique system calls, file systems, and user interface guidelines. For instance, in terms of file systems used to manage how data is stored and retrieved on a disk drive, Windows uses NTFS, while macOS uses APFS, and Linux most often relies on ext4. These differences can cause discrepancies in how software functions and manages files. The testing team's application has to handle these differences seamlessly, which requires extensive testing using virtual machines and conditional coding practices. They also have the option of using Docker containers, which can encapsulate an application and its dependencies, ensuring consistent behavior across different environments. Second, libraries and APIs available on one platform might not be available on another. Jamila's team has to ensure that their application does not rely on platform-specific libraries unless absolutely necessary. When unavoidable, they have to use preprocessor directives or abstraction layers to manage different libraries on different platforms. Third, maintaining a consistent user experience across platforms is challenging. Each OS has its design language, and users expect software to adhere to these conventions. Jamila tells her team to use frameworks like Qt and Electron. These powerful cross-platform development frameworks allow developers to create applications that run seamlessly across different operating systems. They're essential tools in a developer's toolkit, especially when aiming for consistency and performance across platforms like Windows, macOS, and Linux. But software compatibility isn't the only challenge. Jamila's team also has to address file management-related issues. Transferring files between different operating systems can be a complex task due to differences in file systems and metadata handling. Files created on one operating system sometimes exhibit compatibility issues when transferred to another. For example, macOS might create hidden files like .dsstore that are irrelevant on Windows and can cause clutter. Jamila's team has to implement a cleanup script that removes such files before transferring them. They can also use cloud storage, which provides a unified platform for file storage and management. By using cloud storage solutions, files are stored in a standardized format accessible from any OS, eliminating compatibility issues like hidden files and metadata inconsistencies. Each OS handles file metadata and permissions differently. Jamila notices that files transferred from Linux to Windows often lose their permission settings, leading to access issues. To resolve this, she suggests that the team use tools like rsync, which preserves file permissions and metadata across transfers. Lastly, different operating systems use different default character encodings, which can lead to corrupted file contents when transferred. Jamila instructs her team to standardize the project using UTF-8 encoding, ensuring consistent file handling across all platforms. After running through the list of possible causes with her team and directing them on how to resolve the various possible causes, Jamila leaves the team to their work. Later that day, she receives another call from the testing team. This time, the news is good. The application ran flawlessly on all targeted operating systems. Files were transferred without corruption, and user interfaces remained consistent across platforms. Jamila's team's use of virtual machines for extensive testing, Docker containers for consistent environment replication, and cloud applications for seamless file management proved to be highly effective. By standardizing UTF-8 encoding and employing cleanup scripts to handle hidden files, the team ensured file integrity across OS boundaries. Furthermore, the integration of cross-platform frameworks like Qt and Electron provided a unified user experience adhering to each operating system's unique design language. The team's success demonstrates the efficacy of a strategic approach and the importance of using the right tools, thorough testing, proactive problem-solving, and robust file management practices to achieve true cross-platform compatibility. Resetting a computer is an essential task for anyone looking to improve performance, enhance security, or prepare a device for a new purpose. This process involves deleting personal files, uninstalling programs, wiping disks, and restoring factory settings. This video provides a guide on how to reset computers running different operating systems using a scenario and also explores the benefits and risks associated with resetting a computer. Let's turn our attention to the scenario. A small business owner recently instructed Ali, his IT support person, to get some computers ready for new employees. To ensure data security and optimal user performance, he needs to reset the existing machines. Each computer has a different operating system: Windows 11, macOS, and Linux. Because he is dealing with more than one operating system, Ali needs a clear plan to reset each device efficiently. He starts with the Windows 11 computer. This OS offers a straightforward way to reset the system while keeping or removing personal files. Here's how Ali proceeded. First, to back up important data, he connected to an external hard drive and used the built-in Windows backup tool to ensure all critical files were safely stored. Second, he used the reset options. First, he navigated to Settings, selected System, and then selected Recovery. Under Reset this PC, he selected Reset this PC again to begin the reset process. Ali chose the Remove Everything option to ensure a complete reset, preparing the device for a new user. He then selected Cloud Download to get the latest version of Windows from the internet. At the end, by following the on-screen instructions, he completed the reset process, which included formatting the hard drive and reinstalling Windows 11 from scratch. All software applications also had to be reinstalled. Next, Ali tackled the macOS computer. The process for resetting a Mac involves erasing the hard drive and reinstalling the operating system. Let's work through the steps. In the first step, he used Time Machine to back up important files to an external drive. Then he signed out of iCloud, iTunes, and other Apple services to ensure the device was detached from the current Apple ID. Following this, Ali restarted the Mac and held down Command and R until the Apple logo appeared. This action boots the system into recovery mode. In recovery mode, he opened Disk Utility, selected the startup disk, and clicked Erase. He chose Mac OS Extended, Journaled as the format. After erasing the disk, Ali exited Disk Utility and selected Reinstall Mac OS from the recovery menu. He followed the prompts to install a fresh copy of Mac OS. Finally, he needed to reset the Linux computer. Linux systems can vary significantly, but the general approach involves using the terminal or a live USB drive. To back up data, he copied important files to an external drive using the rsync terminal command. Then, to create a live USB, he downloaded the latest version of the Linux distribution, like Ubuntu, and created a bootable USB using Rufus on a Windows machine or Etcher on a Mac. After this, Ali inserted the USB drive, restarted the computer, and booted from the USB by selecting it in the BIOS or UEFI boot menu. As the last step, he selected the option to install Linux, choosing the Erase Disk option, and installed Ubuntu or the respective distribution. This step formats the drive and installs a fresh copy of the operating system. Now that we have worked through the process of resetting computers running 3 different OSs, let's examine the benefits of resetting a computer. Removing accumulated junk files, outdated settings, and unnecessary applications can significantly speed up the system. A fresh installation eliminates malware, adware, and other security threats that may have compromised the system. And wiping the disk ensures that personal data is securely removed, making it safe to repurpose or sell the computer. However, there are also risks to consider. Resetting a computer will result in the loss of all data unless it is properly backed up. Custom settings, software configurations, and licenses may be lost and need to be reconfigured or reactivated. And the reset process, including backup, reset, and reinstallation of applications, can be time-consuming. In summary, by following the outlined steps, Ali successfully reset the office computers, ensuring they are ready for their new users. Whether improving performance, enhancing security, or preparing for a new user, resetting a computer is a valuable skill that ensures the device runs optimally and securely. Well done on completing this module. This part of the course guided you through the world of operating system troubleshooting, helping you gain valuable insights into resolving software and system-related issues across Windows, Linux, and macOS environments. After completing this module, you should now be able to describe software issues and use tools for troubleshooting across different operating systems, identify system-related issues and their resolutions, and discuss different operating system environments, problems, and how to solve them. Let's review what you've learned to make sure you're ready to take the module quiz. In the first part of the module, you learned about the functions of different software components and their role in overall system performance. Then you identified potential issues like errors, crashes, and bugs. Next, you moved on to troubleshooting common software problems and what preventative measures and best practices you can implement to avoid them. For example, regular updates and patches and proper configuration management can prevent various issues from occurring. The importance of log analysis for software troubleshooting was emphasized, and the basics of interpreting log files to diagnose issues effectively were provided. Additionally, you examined compatibility and update problems and their solutions, gaining insight into how to manage and resolve these challenges. For instance, running compatibility mode, installing the latest patches, and checking software versions. You also investigated BIOS, boot, and firmware troubleshooting using various methods like accessing BIOS settings, using the boot menu, and updating or reinstalling the firmware. To round off this section, you explored common browser issues and their solutions, equipping you with the knowledge to handle internet-related problems. And through an activity, you learned how to optimize system performance through CPU and memory resource management. The second part of the module focused on system-related issues. Here you began by assessing the boot sequences and modes of different operating systems. You then explored safe mode and recovery options, discovering how these tools can resolve critical system failures by repairing, restoring, or resetting a system in Windows, macOS, and Linux. Additionally, the importance of user account control or UAC in Windows was discussed, emphasizing its role in preventing unauthorized changes, enforcing security rules, and managing user rights. You also learned how to configure UAC in Windows. Next, you tackled user account and permission issues, and you were provided with strategies to resolve access problems caused by forgotten passwords, locked accounts, and access denied issues. You also delved into Windows activation and authentication challenges and how to resolve them using tools and techniques such as the product key, activation troubleshooter, and a password reset disk. Furthermore, tools like System Restore and System File Checker were covered to help you understand how they can benefit you during troubleshooting, help you maintain system integrity, and recover from errors. In an activity, you created a password reset disk, a practical skill crucial for recovering access to local accounts in Windows. In the final part of the module, your attention shifted to the different operating system environments of Windows, macOS, and Linux. You compared and contrasted their features and functions. The differences between various Windows editions and their unique features were also discussed, helping you choose the right version for specific needs. Next, cross-platform software and file management were covered, along with the challenges they present to ensure compatibility and functionality across different OS environments. You also investigated common issues specific to macOS and Linux and their solutions to enhance your ability to handle problems unique to these systems. The Linux reading in particular went into quite a bit of detail since Linux troubleshooting involves a lot of command line tool usage. Additionally, the process of resetting a computer running different operating systems was explained, preparing you for situations where a system needs to be repurposed. You also learned about the benefits of resetting a computer, such as improving performance, security, and privacy. But don't forget that these benefits are offset by possible risks like losing data, settings, and software licenses. A practical activity in this part of the module involved preparing a USB drive with a common file system for cross-platform file sharing, helping you to facilitate file transfers between different operating systems. Now, after having completed the module, you are equipped to troubleshoot software and system-related issues across various operating systems. As you prepare for the module quiz, remember that you can return to any of the videos, readings, or activities if you feel like you need to reinforce your understanding of key concepts or tools. Good luck with the quiz. You've got this. Knowing how to use diagnostic tools and utilities can save time and frustration when confronted with a computer problem. These tools help identify the root cause of the issue, allowing for a more targeted and effective solution. This video addresses the practical application of various diagnostic tools, illustrating their use through a scenario involving common software and hardware issues. Let's set the scene. An employee is in the middle of a really busy week at work when his Windows computer suddenly becomes painfully slow. He contacts Malika, the IT support person, to help him resolve the issue. Being well-versed in IT troubleshooting, she immediately turns to her toolkit of diagnostic tools and utilities to identify the cause and resolve the problem. Her first step in diagnosing the cause of the slow computer is to use performance monitoring tools. These tools help track a system's performance in real time, providing data on CPU usage, memory consumption, disk activity, and network usage. Since it is a Windows system, she starts with the Task Manager by pressing Ctrl, Shift, and Escape at the same time to open it. Under the Performance tab, there is a real-time graph of CPU, memory, disk, and network usage. If the CPU or memory usage is consistently high, it could indicate that a particular process or application is consuming excessive resources. For a more detailed analysis, she uses the Resource Monitor. She opens it from the Task Manager by clicking on the ellipsis menu in the top right-hand corner and then selecting Resource Monitor. Resource Monitor provides more granular data, allowing her to check which processes are responsible for the high resource usage. She has the option to sort by CPU, disk, network, and memory to pinpoint the culprit. Understanding the information provided by diagnostic tools is crucial. For instance, if the Resource Monitor indicates high disk usage by a process named service host sysmain, it suggests that a Windows service is causing the issue. Disabling the sysmain service via the Services app can resolve this. You can access the app by typing services.msc in the Run dialog box and then pressing Enter. However, while the performance monitors indicate high resource usage, Malika can't pinpoint a specific application, so the next step is to perform a diagnostic startup. This helps determine if a background application or service is causing the issue. She performs a clean boot by using the System Configuration tool. She has to press the Windows button and R at the same time to open the Run dialog box, type msconfig, and then press Enter. Under the Services tab, she ticks the box to hide all Microsoft services and then selects Disable All. Next, she goes to the Startup tab and selects Open Task Manager. She disables all startup items and restarts the computer. If the computer's performance improves, she can then proceed to re-enable services and startup items one by one to identify the culprit. Unfortunately, the computer's performance doesn't improve after she disabled all startup items and restarted the computer. In other words, Malika's software diagnostics did not resolve the issue, which indicates that it might be hardware-related. Most manufacturers provide diagnostic tools to check hardware components to help identify these kinds of problems. Windows includes built-in diagnostics such as the Memory Diagnostic tool. Malika accesses it by typing Windows Memory Diagnostic in the Start menu, pressing Enter, and then following the prompts to restart and test the computer's memory. After the test is complete, the computer restarts and the results are displayed in a notification in the Windows notification area. The message reads, Windows Memory Diagnostic found hardware problems. This message most often indicates a RAM issue, and after investigating, Malika finds that one of the RAM sticks is faulty and needs to be replaced. If it was necessary to do more comprehensive hardware checks, Malika could have used third-party tools like HW Monitor or Crystal Disk Info to check for issues with the CPU, GPU, and storage devices. In this case, she only needs to replace the RAM and test the performance again before returning the computer to the employee. When Malika returns the employee's computer, she makes sure to ask him to monitor the performance and let her know if the issue persists. The system's performance has improved drastically after her troubleshooting and hardware fix, but now the computer's internet is really slow, so he contacts Malika again. This time, she uses network diagnostic tools to identify and resolve the problem. Her first step is to use the built-in network troubleshooter. She accesses it by going to Settings, System, Troubleshoot, Other Troubleshooters, and then Network and Internet. This tool automatically detects and fixes common network problems. Luckily, this is the only necessary step to solve the employee's internet speed issue. The troubleshooter identified misconfigurations in the network adapter settings as the cause of the problem, and it automatically fixed the issue by reconfiguring the necessary settings. In summary, using diagnostic tools and utilities effectively can significantly streamline the troubleshooting process. By following a systematic approach starting with performance monitoring, conducting diagnostic startups, checking hardware components, and finally using network diagnostics, Malika efficiently identified and resolved the employee's computer issues. These tools provide invaluable insights that can help maintain optimal system performance and ensure that productivity is not hindered by technical difficulties. Imagine you're an IT professional tasked with maintaining a high-performance workstation in a busy office. The team relies on this machine for resource-intensive tasks like video editing and data analysis. One day, the workstation starts lagging during a crucial video render, and your team is on edge as their deadline approaches. This is where Task Manager and Resource Monitor become indispensable tools that can help you diagnose and resolve performance issues effectively. By now, you know a little bit about both, but this video goes into more detail about what Task Manager and Resource Monitor have to offer. Instructions on how to access the different sections of these tools are included, and you're encouraged to open them and follow along. Let's start with Task Manager. Task Manager is a powerful built-in utility in Windows that provides a comprehensive overview of the processes, services, and applications running on your computer. You can access it by pressing Ctrl, Shift, and Escape simultaneously. It offers several tabs, each serving a distinct purpose. First up is the Processes tab. It displays a list of all running processes, including applications and background processes. You can view details such as CPU, memory, disk, and network usage for each process. This helps identify resource-hungry processes that might be causing performance bottlenecks. Next is the Performance tab. Here you can monitor real-time performance metrics for CPU, memory, disk, network, and GPU. It provides graphs and detailed statistics that help you understand how your system resources are being used, while App History allows you to view applications' resource usage history. This is particularly useful for identifying which apps consume the most resources over time. The Startup tab lists all the programs that start automatically when Windows boots. Disabling unnecessary startup programs can significantly improve boot times and overall system performance. There is also the Users tab. It provides information about the currently logged-in users and their resource usage. It's useful in multi-user environments to monitor and manage resource allocation. Another tab is the Details one. It offers advanced details about each process, including process ID or PID, status, and resource usage. It's especially useful for IT professionals and advanced users who need granular control over processes. And finally, there is a Services tab. This section lists all Windows services, their statuses, and their associated processes. You can start, stop, or restart services directly from this tab. Now let's turn our attention to Resource Monitor, also known as ResMon, another built-in Windows tool that provides a detailed analysis of system resource usage. You can access it through the Performance tab. When that tab is open, select the three-dot menu at the top right corner of the window. Then select Resource Monitor from the drop-down menu. This tool complements Task Manager by offering in-depth insights into CPU, memory, disk, and network activity through 5 different tabs. First is the Overview tab. It is similar to the Task Manager's Processes tab because it provides a summary of CPU, disk, network, and memory usage. However, it gives you more detailed and granular data about resource usage and system performance than the Processes tab. This helps you pinpoint which processes are using the most resources, thereby assisting you in identifying potential performance issues quickly. Second is the CPU tab, which displays detailed information about CPU usage, including the processes and services consuming CPU cycles. It also shows threads, handles, and module details, which can be useful for diagnosing complex performance issues. Third is the Memory tab. This section provides a detailed breakdown of memory usage, including physical memory, standby memory, and memory used by each process. It helps identify memory leaks and processes that consume excessive memory. Fourth is the Disk tab, which shows real-time disk activity. This includes read and write operations, disk queue length, and which processes are accessing the disk. It's useful for identifying disk bottlenecks and processes causing high disk input-output. Fifth and the last is the Network tab, which displays network activity, including processes with network activity, TCP connections, and network utilization. It helps you to diagnose network-related issues and monitor network traffic. Both Task Manager and Resource Monitor offer numerous benefits that help maintain system health. By monitoring CPU, memory, disk, and network usage, you can identify processes that consume excessive resources and take appropriate actions, such as ending or troubleshooting them. Disabling unnecessary startup programs through Task Manager can improve boot times and overall system performance. And real-time performance metrics help you understand how your system is performing and identify potential bottlenecks. Furthermore, Task Manager allows you to end unresponsive programs, freeing up system resources and restoring stability. You can also start, stop, or restart services directly from Task Manager, ensuring that critical services run smoothly. If you need to diagnose network issues, Resource Monitor's Network tab helps you identify processes causing high network usage, diagnose network-related issues, and monitor network traffic. And lastly, by identifying suspicious processes and network activity, you can detect and terminate potential malware or security threats. Task Manager and Resource Monitor are essential tools for maintaining optimal system performance, security, and stability. Whether you're troubleshooting unresponsive programs, managing system resources, or diagnosing network issues, these tools provide the insights and control needed to keep your computer running efficiently. By leveraging their capabilities, you can ensure a smooth and responsive computing experience even under demanding conditions. Today, we are discussing two essential Windows tools, disk management and disk cleanup. Let's do so through a scenario to help you understand how you'd use these tools in a practical situation as an IT professional. Yasmin is an IT manager at a growing tech company. She is responsible for maintaining the health and performance of dozens of Windows systems used by her team. Recently, she noticed that several computers were running out of disk space, causing performance issues and hindering productivity. To address these problems, Yasmin decides to use disk management and disk cleanup. Disk management is a powerful system utility in Windows that allows you to perform advanced storage operations. Yasmin uses this tool to create, format, and resize partitions and assign drive letters. This enables her to manage disk space effectively and ensure that each system is optimized for performance. She starts by creating new partitions on the hard drives of her team's computers. A partition refers to a division of a computer's hard disk drive or solid-state drive into separate, distinct sections. Partitions are used to organize data, improve performance, and enable multiple operating systems to run on the same physical disk. To access disk management, she types Create and Format Hard Disk Partitions in the Windows taskbar search box and selects the relevant app. To create a partition, she right-clicks on an unallocated space in Disk Management and selects New Simple Volume. She then follows the wizard to specify the size, assign a drive letter, and format the partition. Occasionally, Yasmin needs to adjust the size of existing partitions to accommodate growing data requirements. Disk management allows her to extend or shrink partitions without data loss. By right-clicking on a partition and selecting Extend Volume or Shrink Volume, she can modify the partition size as needed. To keep the file system organized, she assigns drive letters to partitions and drives. This makes it easier for her team to locate and access their files. She right-clicks on a partition, selects Change Drive Letter and Paths, and assigns an appropriate letter. Disk management also provides her with valuable information about the health of the disks. She can view each disk's status, identify errors, and take necessary actions to resolve issues. As the team's projects progress, temporary files, system files, and other unnecessary data accumulate on their computers. This is where disk cleanup comes into play. Disk cleanup is a maintenance tool that helps Yasmin enhance system performance by freeing up hard drive space. First, to remove unnecessary files, she launches Disk Cleanup by typing Disk Cleanup in the Windows taskbar search box and selecting the app. She then chooses the drive she wants to clean and allows the tool to calculate the amount of space that can be freed. Disk Cleanup shows a list of file types that can be removed, such as temporary files, system files, and cached files. Yasmin carefully chooses the files to be removed and selects OK to delete them. For a more thorough cleanup, she clicks on Cleanup System Files in Disk Cleanup. This option scans for additional files that are safe to delete, such as old Windows updates and system error memory dump files. Removing these files can free up significant space and enhance the computer's performance. She selects the files that are no longer needed and confirms the cleanup. While maintaining the systems, Yasmin encounters various disk-related issues, and both disk management and disk cleanup prove invaluable in troubleshooting these problems. She often notices that some disks show errors or bad sectors. Using disk management, she can run the Check Disk utility to scan and repair disk errors. This tool helps her identify and fix issues that could potentially lead to data loss or system instability. As the team works on large projects, disk space becomes a critical resource. By regularly using disk cleanup, she ensures that unnecessary files do not consume valuable space. This proactive approach helps prevent storage-related slowdowns and keeps the systems running smoothly. Beyond disk management and disk cleanup, Yasmin also uses the Windows Media Creation tool to manage and deploy Windows installations. This tool allows her to create bootable USB drives or ISO files, which are essential for installing or reinstalling Windows on her team's computers. She downloads the Windows Media Creation tool from the official Microsoft website. She runs the tool and selects Create Installation Media for another PC. By following the prompts, she can create a bootable USB drive or an ISO file that can be used for Windows installations. When a system encounters severe issues that cannot be resolved through troubleshooting, she uses the installation media to perform a clean installation of Windows. This ensures that the system is reset to its original state, free of any software conflicts or errors. Yasmin's scenario demonstrates the importance of regular maintenance and proactive disk management and how disk management and disk cleanup can facilitate them. These tools not only help optimize disk space and improve system performance, but also play a crucial role in troubleshooting disk-related issues. With the addition of the Windows Media Creation tool, she has a comprehensive set of utilities to manage, troubleshoot, and maintain Windows systems effectively. By incorporating these tools into her routine maintenance tasks, Yasmin can make sure that her team's computers remain efficient and reliable, supporting their productivity and project success. Zara, a network administrator at a mid-sized company, was sipping her morning coffee when an urgent call came through. The finance department couldn't access their shared drive, and the problem seemed to be network-related. This is not an unusual occurrence. Network connectivity and configuration issues are common headaches in both home and enterprise environments. This video will help you understand how to diagnose and resolve these problems by walking you through common causes of network connectivity issues and how Zara solved the finance department's problem. Let's start with why these problems crop up in the first place. Network connectivity issues happen when devices fail to communicate with each other over a network. These issues can manifest as an inability to access the internet, connect to a shared resource, or communicate between networked devices. Configuration problems, on the other hand, stem from incorrect settings within network devices or software, leading to improper routing, inaccessible services, or degraded performance. Here are some common causes of network connectivity issues. Faulty cables, loose connections, or malfunctioning network interfaces can disrupt communication. Incorrect IP addresses, subnet masks, or default gateways can prevent devices from finding each other on the network. Also, domain name system or DNS problems can prevent domain names from resolving to their respective IP addresses. DNS is a hierarchical and distributed naming system used to translate domain names into IP addresses necessary for locating and identifying devices on a network. Furthermore, misconfigured or failing routers and switches can block or misroute traffic. And outdated or buggy software and firmware can introduce connectivity issues. So what are the steps you should take when troubleshooting network problems? Zara knows the first step in troubleshooting is verifying the physical connections. So she begins with a visual inspection of the network cables and ports in the finance department. Everything appears intact, but appearances can be deceiving. So Zara also uses a cable tester to confirm the cables are all functional. With the physical layer seemingly in order, Zara turns to Windows command line tools. She starts with the ping command to test connectivity between a finance department computer and the company's main server. The ping response indicated that packets were not reaching the server. To dig deeper, Zara uses the trace route command to trace the path packets took to reach the destination. The output reveals that packets were getting lost at the company's core switch. This suggests a potential issue with the switch or its configuration. So let's examine some common configuration issues and their solutions. Firstly, misconfigured IP addresses, subnet masks, or gateways can prevent devices from communicating properly on the network. Ensuring that devices receive correct configurations, either manually or via DHCP, is essential. DHCP stands for Dynamic Host Configuration Protocol. It is a network management protocol used on IP networks where a DHCP server dynamically assigns IP addresses and other network configuration parameters such as subnet mask, default gateway, DNS servers, and so on to devices on the network. Secondly, incorrect subnet masks can lead to devices being placed in the wrong network segments, causing communication failures. A subnet mask is a 32-bit number used in conjunction with IP addresses to divide a larger network into smaller subnetworks or subnets. It helps determine which part of an IP address represents the network identifier and which part represents the host identifier within that network. It's important to configure subnet masks that match the network's design. Thirdly, the default gateway is critical for directing traffic to external networks. A gateway refers to a network node, usually a router, that serves as an entry and exit point for data packets between networks using different protocols. Incorrect gateway settings can isolate a device from external networks even if local connectivity is intact. And misconfigured gateways can lead to internet connectivity issues. Zara verifies that the finance department's IP, subnet, and gateway settings are correct using the ipconfig Windows command. Lastly, DNS settings must point to valid DNS servers. Zara verifies and updates the DNS entries on client devices to address any incorrect settings. Having confirmed that all of the configurations are in order, Zara suspects that the issue lies with the switch itself. She accesses the core switch's configuration interface and notices it had recently rebooted, potentially due to a power glitch, reverting to an older, incorrect configuration. She reloads the latest configuration file and monitors the switch as it applies the changes. After running the traceroute command on the switch, it confirms that packets are now reaching the server without any issues. Note that the traceroute command is written out in full if used on a switch or router, while it is written as traceRT if used on a Windows computer. To prevent future occurrences, Zara implements a regular backup schedule for network device configurations and installs an uninterruptible power supply to protect against power fluctuations. With the core switch functioning correctly, Zara revisits the finance department's connectivity. The devices are now able to access the shared drive, confirming that the issue has been resolved. In conclusion, like any troubleshooting process, troubleshooting network connectivity and configuration issues requires a methodical approach. Starting with physical connections, using command line tools for deeper insights, addressing common configuration errors, and examining switch errors can resolve most problems. Zara's systematic approach not only restored network functionality, but also highlighted the importance of maintaining up-to-date configurations and protecting network infrastructure from physical disruptions. Through careful diagnosis and timely intervention, network administrators can ensure reliable connectivity, keeping business operations smooth and efficient. Zara, the network administrator who solved the finance department's drive access problem, is once again faced with a challenge when employees begin reporting intermittent connectivity issues and slow internet speeds. To maintain productivity and ensure smooth operations, she needs to diagnose and resolve these network problems efficiently. This video explores how Zara uses various network diagnostic tools such as ping, traceroute, netstat, nmap, and wireshark to troubleshoot and resolve the network issue. She starts with the most basic diagnostic tool, ping. Ping is used to test the reachability of a host on an IP network and measure the round-trip time for messages sent from the originating host to a destination computer. To use it, you have to use the command prompt. First, open the dialog box by pressing the Windows button and R at the same time. Then you type CMD and press Enter to open the command prompt. Then, to use ping, you have to type the word ping followed by the destination website. So Zara executes the command by typing ping www.google.com. The output indicates packet loss and high latency, suggesting a potential issue with network connectivity. By pinging more destinations, Zara identifies that the problem is not isolated to a single host, but affects various parts of the network, indicating a broader network issue. Next, she employs traceroute to determine the path packets take to reach their destination and identify where delays or failures occurred. Traceroute helps in pinpointing the exact location of the problem within the network. She executes the command by typing traceroute www.google.com. The traceroute results showed that the packets experienced significant delays and packet loss after reaching a particular router. This information helps Zara narrow down the problem to a specific segment of the network between the company's internal router and the ISP. To gather more details about the network's overall health and check for unusual connections or network traffic, Zara turns to netstat. This tool displays network connections, routing tables, interface statistics, masquerade connections, and multicast memberships. The netstat output revealed an unusually high number of connections to a specific IP address, indicating a possible security issue such as a denial of service attack or malware infection. Suspecting a potential security threat, Zara decides to use Nmap, a powerful network scanning tool, to get a clearer picture of the network's security posture. Nmap is capable of scanning the network to detect open ports and identify all connected devices. It provides comprehensive details about the devices on the network, including their open ports and the services running on those ports. This information is crucial for identifying unauthorized access points and potential vulnerabilities. To use it, you need to type the command, supply the type of scan, and the target network range. To perform a thorough scan of the entire subnet, Zara executes this command. The -SS option specifies a TCP SYN scan, which is a more stealthy and efficient way of identifying open ports. The target network range encompasses all devices within that subnet. The results from the Nmap scan are revealing. Multiple devices are found to have unexpected open ports, indicating unauthorized access points and potential security vulnerabilities. These open ports could be exploited by malicious actors to gain access to the network or disrupt its operations. To gain deeper insights into the network traffic and diagnose complex issues like packet loss and latency, Zara uses Wireshark. This tool captures and analyzes network packets in real time, providing detailed information about each packet. She starts Wireshark, selects the network interface to capture traffic, and then she applies a filter to narrow down the captured data. By analyzing the captured packets, Zara identifies abnormal traffic patterns and discovers that one device is generating a large amount of broadcast traffic, causing network congestion. This device needs to be isolated and reconfigured to prevent further issues. Zara now has a comprehensive view of the network's health and the underlying issues. Here is a summary of the steps she takes to resolve the problem based on the information she gathered. The high latency and packet loss identified using ping and traceroute were due to a faulty router. Zara replaced the router, which significantly improved the network performance. The unusual network connections found with netstat and the unauthorized open ports identified by Nmap were addressed by updating the firewall rules and securing the network devices. Finally, the broadcast storm caused by a misconfigured device identified through Wireshark was resolved by reconfiguring the device to minimize unnecessary broadcast traffic. By methodically using network diagnostic tools such as ping, traceroute, netstat, Nmap, and Wireshark, Zara was able to diagnose and resolve complex network issues. These tools provided vital insights into different aspects of the network, from connectivity and path analysis to security and traffic patterns. The successful resolution of these issues ensured a stable and efficient network, allowing the company's operations to continue smoothly. Ishan, a small business owner, is preparing for an important virtual meeting with the potential client. As the clock ticks down, his Wi-Fi starts acting up, causing severe lag and dropped connections. This scenario is all too familiar for many users who rely heavily on their wireless networks for professional activities. Luckily, effective network troubleshooting can save the day. Let's walk through a process Ishan can use to diagnose and resolve his wireless networking issues, ensuring a smooth and stable connection. The first step he can take is to verify the wireless adapter settings on his devices. Sometimes simple misconfigurations can cause significant connectivity issues. Ishan checks his laptop to ensure that the wireless adapter is enabled and correctly configured. He also verifies that the device is set to obtain an IP address automatically. This default setting can sometimes be manually changed, causing network conflicts. With the adapter settings confirmed, he moves on to check the Wi-Fi signal strength. Weak signal strength can cause slow connections and frequent disconnects. Using a tool like a Wi-Fi analyzer, Ishan can visualize the signal strength in different areas of his office. Wi-Fi analyzers provide a graphical representation of the network's signal strength and can highlight areas with weak coverage. He notices that the signal strength in his office drops significantly near the back of the room and realizes that his router's placement might be causing this issue. Routers should be placed in a central location, elevated, and away from obstructions like walls and large furniture. Ishan decides to move his router to a more central position to ensure better coverage throughout the office. Even with the router repositioned, Ishan's connection issues persist. The next step is to identify potential interference sources. Wireless networks operate on specific frequency bands, which can be crowded by other devices using the same frequencies. Common sources of interference include microwaves, cordless phones, and other Wi-Fi networks. Using the Wi-Fi analyzer, Ishan scans the surrounding environment and identifies several other networks operating on the same channel as his. This overlap can cause significant interference, reducing network performance. To mitigate this, he decides to change the channel on his router. Most modern routers offer an automatic channel selection feature, but manually selecting a less crowded channel can often yield better results. Changing the wireless channel is straightforward. Ishan logs into his router's web interface and navigates to the wireless settings. Here he can view the current channel and select a new one. After switching to a less congested channel, he immediately notices an improvement in his network's performance. The connection is more stable and the signal strength is stronger throughout the office. Next, Ishan updates the firmware on his router. Router manufacturers frequently release firmware updates to improve performance, add new features, and address security vulnerabilities. Keeping the firmware up to date can resolve connectivity issues and enhance the overall network stability. Ishan logs into his router's web interface again, checks for available updates, and installs the latest firmware. With the firmware updated, the network is performing well, but there are still occasional slowdowns. To further optimize his network, Ishan explores some advanced troubleshooting techniques. One option is to adjust the quality of service or QoS settings on his router. QoS prioritizes network traffic, ensuring that high-priority applications like video conferencing receive the necessary bandwidth. He configures QoS settings to prioritize his laptop and Voice over Internet Protocol or VoIP applications, ensuring that his virtual meetings and phone calls take precedence over other, less critical network activities. This adjustment helps maintain a consistent, high-quality connection for his important business communications. Another critical aspect of maintaining a reliable wireless network is ensuring its security. Unsecured networks can be accessed by unauthorized users, leading to potential performance issues and security risks. Ishan ensures that his network uses WPA3 encryption, the latest and most secure wireless encryption standard. He also disables Wi-Fi Protected Setup or WPS, a feature that can be exploited by attackers to gain access to the network. And by implementing a strong, unique password for his Wi-Fi network, he adds another layer of protection against unauthorized access. Ishan's process demonstrates the importance of a structured approach to wireless network troubleshooting. From checking basic settings to implementing advanced techniques, each step plays a crucial role in diagnosing and resolving common issues. By following these steps, users like Ishan can ensure their wireless networks provide reliable and robust performance, supporting their business activities without interruption. When Nashira, an IT manager at a mid-sized tech company, received an alert that a crucial server had crashed, she knew she was in for a long night. The initial symptoms were vague: intermittent connectivity, sporadic data corruption, and inexplicable slowdowns. These signs point to an uncommon and potentially complex issue that requires a deep dive into the system's intricacies. Complex issues, like Nashira's server crash, often involve multiple layers of interdependencies and variables. These can include hardware failure, software corruption, data loss, and network anomalies. Unlike straightforward problems, these issues are not easily diagnosed with a single test or a standard procedure. They require a methodical and analytical approach to identify the root cause. So let's go through how Nashira explored the possible causes of the server crash. She first suspects hardware failure. Hardware issues can manifest in diverse ways, from a failing hard drive causing data read-write errors to a faulty RAM module leading to random crashes. In Nashira's case, the server's logs indicate intermittent read errors from one of the hard drives, suggesting a potential disk failure. Another potential cause is software corruption. This occurs when software components become damaged due to bugs, malware, or improper updates. Software corruption often presents itself through erratic behavior, such as applications crashing or system processes failing to execute correctly. Nashira recalls a recent patch update that could have introduced compatibility issues. Third, data loss is a particularly challenging issue, especially when it is partial or sporadic. Nashira notices that some files on the server are corrupted while others remain intact. This inconsistency suggests that the problem is not just with the storage medium, but possibly with how the data is being written and retrieved. There are also several factors that contribute to the complexity and rarity of these issues, which makes them difficult to diagnose and resolve. For example, the interaction between hardware, software, and network components adds layers of complexity. Nashira's scenario involves a mix of new and old hardware, different versions of software, and varying configurations. Each of these variables could potentially contribute to the problem. Next, modern IT environments are highly interdependent. A change in one component can have cascading effects on others. For instance, Nashira's team had recently upgraded their network infrastructure. The new configurations might have introduced latency or compatibility issues that were not immediately apparent. Also, uncommon issues are, by definition, rare and often undocumented. This means there is little to no prior knowledge or established procedures to fall back on. For example, Nashira can't find any exact matches in the knowledge base or online forums, making the troubleshooting process more difficult. Because of all of these factors, she knows that solving this issue will require a very structured approach. Let's walk through the steps she takes in her troubleshooting process. First, she collects all available data: error logs, user reports, and system performance metrics. This information helps her form a preliminary understanding of the problem's scope and possible causes. Second, Nashira aims to isolate the problematic area by systematically disabling and enabling different components. She starts by removing the suspected hard drive and observing whether the errors persist. They do not, so this step confirms that the hardware is indeed part of the issue. Third, she runs integrity checks on the software components. Nashira uses tools to verify the integrity of installed software and compares it against known good configurations. This process reveals that the recent patch update has caused some software modules to become unstable. Fourth, understanding the interdependencies is crucial. She reviews the recent network upgrade and checks for any overlooked compatibility settings. She discovers that a new network driver is causing intermittent connectivity issues, compounding the problem. After identifying the hardware failure, software corruption, and configuration issue, Nashira implements some solutions. She replaces the faulty hard drive and rolls back the problematic patch. She also adjusts the network configurations to ensure stability. With the immediate issues addressed, she conducts thorough testing to ensure the system is stable. And she monitors the server closely over the next few days to catch any residual or emerging problems. Nashira's experience highlights several challenges in troubleshooting complex and uncommon issues. The process is inherently time-consuming. Each step, from data collection to testing, requires careful attention to detail. Troubleshooting often requires significant resources, including specialized tools and expertise. She had to leverage both internal and external resources to resolve the issue. And the impact of these issues can be severe, affecting business operations and data integrity. The affected server is critical for the company's operations, adding pressure to resolve the problem swiftly. Nashira's journey through troubleshooting a complex and uncommon issue underscores the importance of a structured approach, a deep understanding of system interdependencies, and the ability to adapt to unexpected challenges. By systematically isolating variables, verifying software integrity, and understanding interdependencies, she successfully navigated the complexities of the server crash. This case is a valuable lesson for IT professionals facing similar daunting challenges, emphasizing the need for patience, thoroughness, and a strategic approach to resolving the most intricate problems. Kamau, a software developer, recently encountered an issue with his computer while trying to install a critical update for his development environment. The installation failed repeatedly, leaving him frustrated and unable to continue his work. This situation, although distressing, is not uncommon and highlights the challenges many users face with software corruption and installation issues. These kinds of problems can arise from various factors, each with unique symptoms and underlying causes. Here are some of the most common reasons. Missing or damaged files can occur due to several reasons, including improper shutdowns, power failures, or hardware issues. For instance, if Kamau's computer lost power unexpectedly during an update, critical system files could have become corrupted, leading to installation failures. Next, the Windows registry is a repository that holds configuration settings and options for both the operating system and installed software. Over time, invalid entries, leftover remnants from uninstalled software, or malware infections can corrupt the registry, causing software to malfunction or installations to fail. When Kamau tried to install the update, the system might have encountered a registry error, preventing successful installation. Additionally, software incompatibilities often arise when new software versions are released without backward compatibility for older system configurations or hardware. If Kamau was trying to install an update requiring a newer version of a supporting library or framework that was not present on the system, the installation would fail. Lastly, using pirated software can lead to numerous issues, including corrupt installations and malware infections. Pirated versions often lack the necessary updates and support from the original vendor, leading to stability and compatibility issues. If Kamau had been using a non-genuine copy of his development tools, he could face frequent crashes and failed updates. Addressing software corruption and installation issues requires a thorough approach to identify and resolve the root cause. Here are several effective methods. The System File Checker, or SFC tool, is a built-in utility in Windows that scans for and repairs missing or corrupted system files. Running this tool can often resolve installation issues related to damaged system files. To use it, you have to open the command prompt as an administrator. Type sfc/scan now and press enter. The tool will then scan the system and attempt to repair any corrupted files it finds. If a specific application is causing problems, repairing or reinstalling it can often resolve the issue. Most applications have a repair option in the control panel under Programs and Features or in the Apps section of Settings. To use it, navigate to the control panel and then Programs and Features. Select the problematic application and click on Repair if available or uninstall. And after uninstalling, download the latest version from the official website and reinstall it. Furthermore, keeping software and drivers up to date ensures compatibility and stability. Regular updates address known issues and vulnerabilities, reducing the likelihood of corruption. To implement this solution, you should check for updates within the application or visit the official website. And for drivers, use Device Manager in the control panel to update them automatically or download the latest versions from the manufacturer's website. Another potential solution is to use a reliable registry cleaner that can help fix invalid entries and residual data left by uninstalled programs. However, caution is necessary as incorrect changes to the registry can cause system instability. To apply this method, you should download and install a reputable registry cleaner. Then run the scan and follow the prompts to clean up invalid entries. Lastly, using genuine software ensures access to official updates, support, and patches. Pirated software often comes with risks such as malware infections and incompatibility issues. To avoid these problems, you should purchase software only from authorized vendors and regularly check for updates and install them as they become available. Kamau's situation is a clear example of the frustration that software corruption and installation issues can cause. By understanding the common causes and applying systematic troubleshooting methods, users can often resolve these issues efficiently. Using tools like the System File Checker, implementing regular software updates, and maintaining a clean registry are essential practices for ensuring software stability and preventing installation problems. Avoiding pirated software and opting for genuine versions also plays a crucial role in maintaining a healthy computing environment. With these strategies, users like Kamau can minimize disruptions and keep their systems running smoothly. Upgrading or installing Windows can be daunting because it's often plagued by various error codes and issues that can stump even seasoned IT professionals. In this video, we'll discuss the most common errors encountered during Windows upgrades and installations and provide step-by-step solutions to troubleshoot these problems effectively. First, let's turn our attention to the three most common errors and their causes. The first is error 0x80070002. This error typically occurs due to missing or corrupt files required for the installation process. It can also be triggered by incorrect system time and date settings. The second is error 0xC1900101. Often associated with driver issues, it is commonly encountered during the upgrade process. It signifies a problem with incompatible or outdated drivers that prevent the upgrade from completing successfully. The third is the inaccessible boot device error. It indicates that Windows cannot access the system partition during the boot process. It can result from corrupted boot files, incorrect BIOS settings, or issues with the disk itself. Let's go through a step-by-step troubleshooting process you can go through to address these errors during a critical upgrade. Step 1. Before initiating the upgrade, you should ensure that all important data is backed up. Create a system image and verify that the current system meets the minimum hardware requirements for the new Windows version. Step 2. Review the system requirements for the new Windows version and compare them against the specifications of the computers you need to upgrade. This step helps identify any potential hardware incompatibilities that could cause installation errors. Third, to tackle the 0xC1900101 error, you should check the device manager for any outdated or incompatible drivers. Then update all drivers, particularly those related to the motherboard, graphics card, and storage controllers. If necessary, it's also a good idea to visit the manufacturer's website for the latest drivers. In step 4, for errors like 0x80070002, you should run the Windows Update Troubleshooter. This built-in tool scans for issues with the update process and attempts to fix them automatically. The troubleshooter identifies missing files and corrects time and date settings that could disrupt the installation. If automatic updates fail, you may have to resort to the media creation tool. This tool allows you to create installation media on a USB drive. You can then use this media to perform a clean installation of Windows, bypassing any corrupt system files that might cause errors. Furthermore, when presented with the inaccessible boot device error, you should inspect the BIOS or UEFI settings. Ensure that the boot order is correctly configured, with the system disk set as the primary boot device. You should also verify that the SATA mode is set to AHCI, which is compatible with most modern drives. In the last step, for persistent boot errors, use the Windows Recovery environment. To do so, access the command prompt from the Windows Recovery environment and run these commands to repair the boot configuration: fix MBR, fix boot, scan OS, and rebuild BCD. These commands help restore the master boot record, or MBR, and rebuild the boot configuration data, or BCD, resolving issues that prevent Windows from accessing the system partition. Except for these detailed steps, here are some additional tips and considerations. Ensure that all installed software is compatible with the new Windows version, and uninstall any software known to cause conflicts during the upgrade. Insufficient disk space can lead to installation errors. Make sure there is enough free space on the system drive by deleting unnecessary files and programs. Sometimes third-party antivirus software can interfere with the installation process. To avoid conflicts, temporarily disable the antivirus software. Lastly, if errors persist, review the installation logs located in the Panther folder in the Windows Sources directory. These logs provide detailed information about the issues encountered during the upgrade, which will help you pinpoint the root cause. By following these systematic troubleshooting steps and additional tips, you can successfully navigate the complexities of Windows upgrades and installations, ensuring a smooth transition to the latest Windows version. You've finished another module in the course. Great work! You've made so much progress and learned a lot about diagnosing and troubleshooting different types of issues. You should definitely give yourself a pat on the back. This module was all about advanced troubleshooting techniques and equipping you with the skills to resolve complex and uncommon problems. You learned how to use diagnostic tools and utilities, troubleshoot networking scenarios, and handle other complex issues and their resolutions. After completing this module, you should now be able to effectively use diagnostic tools and utilities to identify and troubleshoot computer issues, diagnose and resolve network connectivity and configuration issues, and tackle complex and uncommon problems. Now, before you start the module quiz, let's go over what you learned to help you check that you're ready. In the first part of the module, you learned about various diagnostic tools and utilities available for troubleshooting computer programs such as performance monitors, diagnostic startups, and network diagnostics. It covered how to interpret the information these provide to troubleshoot effectively by identifying and solving hardware and software problems. You explored how to use Windows Troubleshooter to find and fix various system problems related to hardware, software, network, and security. And you learned about Task Manager and Resource Monitor and how they can help you view and manage processes, services, and resources, as well as troubleshoot performance, security, and stability issues. Another set of tools you covered are Event Viewer and System Information. You investigated how to use Event Viewer to view detailed information about significant system events and System Information or MS Info 3.2 for comprehensive hardware and software details. Next, you moved on to using disk management to free up disk space and disk cleanup to remove unnecessary files. For example, disk management can create, format, and resize partitions and assign letter drives, which all help manage disk space. Another tool you learned about is the DirectX diagnostic tool or DXDiag, which can be used to troubleshoot and test the functionality of DirectX components for multimedia applications and games. It can also check the DirectX version and driver information, which helps you resolve compatibility issues and ensure optimal performance for multimedia applications. This section of the course ended with an activity where you learned how to create installation media for Windows, an essential task for performing a clean installation of Windows. Part 2 of the module covered networking scenarios such as troubleshooting network connectivity and configuration issues by checking physical connections and IP configurations and using command line tools. You also explored common configuration issues that can disrupt network connectivity such as incorrect IP settings, subnet mask errors, and gateway misconfigurations. It also covered identifying and resolving DHCP and DNS problems using tools like ipconfig, nslookup, and dig. Additionally, you learned about other network diagnostic tools like ping, traceroute, netstat, nmap, and wireshark to diagnose network problems. The importance of how to interpret and analyze the output of these tools to identify and resolve network issues such as latency and packet loss was emphasized. This section also addressed troubleshooting common VPN and firewall-related connectivity issues, including failed connections and misconfigured rules, as well as wireless network troubleshooting, where you investigated steps for diagnosing and fixing common issues in wireless networking, such as interference, signal strength problems, and configuration problems. You were provided with an overview of the wireless troubleshooting process, from checking wireless adapter settings to analyzing Wi-Fi signal and interference with tools like Wi-Fi analyzers. Troubleshooting approaches for network security and encryption-related problems like SSL certificate errors and security protocol issues were also covered. You learned about strategies to address security breaches, including identifying the source of the breach, containing the impact, and implementing measures to prevent future incidents. The activity in this section required you to apply your networking knowledge to diagnose and propose a solution for a scenario involving a DNS issue. The third part of the module was about complex problems that you don't encounter often. It covered hardware failure, software corruption, and data loss issues and their challenges, which are related to factors like multiple variables and interdependencies. Furthermore, you learned about the benefits of hardware warranties and strategies for managing warranty claims effectively. You also explored troubleshooting methods for software corruption and installation issues, such as missing files, registry errors, and incompatible software. Troubleshooting methods include reinstalling, repairing, updating, or uninstalling the software. And you examined how certain software actions like overwriting firmware, incorrect driver installations, or causing components to operate beyond their safe parameters can lead to hardware damage. Next, you investigated Windows upgrade and installation errors and learned steps to resolve them. And you identified recovery options in Windows such as System Restore, Reset this PC, and Fresh Start, and their effects and impact. The activity for this part of the module walked you through a systematic approach to diagnose and resolve complex and uncommon technical problems. Now, the last step to complete the module is to take the module quiz. If this video helped you identify any areas that require revision, review the relevant videos, readings, or activities to ensure you're well prepared. Best of luck with the quiz. Congratulations on reaching the final part of the course. The purpose of this course was to equip you with essential skills to systematically diagnose and resolve technical issues across various hardware and software environments. After completing the course, you should now be able to apply a systematic approach to diagnose technical issues across different hardware and software environments, implement troubleshooting skills to resolve problems effectively, and use diagnostic tools and techniques for problem resolution. This recap provides an overview of what you have covered, helping you identify areas you might want to revisit before starting the final activity and assessment. Let's begin. In the first module, you were introduced to the foundational concepts of troubleshooting. You learned about the significance of troubleshooting in maintaining and repairing technology systems and its role in ensuring system reliability and performance. The module covered different problem-solving strategies and models, providing you with a structured process for effective troubleshooting. First, you explored the four main steps of troubleshooting: identification, analysis, action, and verification. This structured process helps ensure a systematic approach to diagnosing and resolving issues. Next, you discovered the impact of happiness engineering in troubleshooting. In doing so, you learned about the importance of positive and supportive interactions in enhancing user and customer satisfaction. Following this, key troubleshooting strategies and best practices were discussed to enhance your troubleshooting process, including common mistakes IT professionals make, how to avoid them, and how to apply troubleshooting models to given problems. In terms of problem-solving strategies, you learned about root cause analysis, the Kepner-Trago method, the ideal framework, SWOT analysis, and decision matrix. These methodologies and techniques are crucial for analyzing and resolving complex issues systematically. The first module also covered common hardware components, their potential issues, and best practices for diagnosing and resolving these problems. Additionally, you discovered performance measurement tools and their applications, as well as how to troubleshoot audio, video, and printer problems and follow best practices for upgrading and repairing computer components. In the second module, you explored various software issues and tools for troubleshooting across different operating systems, including Windows, Linux, and macOS. Through this exploration, you gained insights into system-related issues and cross-platform problem resolution. You identified common software components and their potential issues, including compatibility and update problems, BIOS and firmware issues, and browser-related troubles. In this part of the course, it was emphasized that analyzing logs for software troubleshooting provides a deeper understanding of system behavior. Additionally, you investigated system-related issues such as troubleshooting boot and startup issues, using safe mode and recovery options, and managing user account and permission problems. You also learned about Windows activation and authentication issues, system restore, and the benefits of using System File Checker. The final part of this module was about comparing different operating systems and the unique features and functions of Windows, Linux, and macOS. You learned about cross-platform software and file management challenges, common issues in each operating system, and how to reset and prepare computers for repurposing. The third module equipped you with advanced troubleshooting techniques and skills for resolving complex and uncommon issues. This included learning how to use diagnostic tools and utilities, troubleshoot networking scenarios, and deal with various other technical problems. Moving on, the module addressed how to effectively use diagnostic tools like Windows Troubleshooter, Task Manager, Resource Monitor, Event Viewer, and Disk Management to identify and resolve computer issues. The DirectX diagnostic tool was also discussed for troubleshooting multimedia and gaming problems. Furthermore, you learned to troubleshoot network connectivity and configuration issues, including DHCP and DNS problems, VPN and firewall issues, and wireless network troubles. Network security and encryption issues were also covered, providing a comprehensive approach to maintaining secure and efficient network operations. Lastly, you explored troubleshooting complex and uncommon issues. Some of the topics covered included understanding hardware warranties, dealing with software corruption, and preventing hardware damage caused by software. You also learned about Windows upgrade and installation errors and various recovery options available in Windows. In the final module, you have the opportunity to apply your troubleshooting knowledge and skills to a realistic and complex problem. You'll be provided with multiple diagnostic outputs and tasked with identifying the issue and recommending a solution. Documenting and communicating your troubleshooting process and outcome is also an essential part of this assessment. This project synthesizes the skills you have acquired, challenging you to apply a systematic approach to diagnose a technical issue across different hardware and software environments. You will implement your troubleshooting skills to resolve the issue effectively and use diagnostic tools and techniques for problem resolution. In conclusion, throughout the course, you have gained both theoretical knowledge and practical skills from understanding troubleshooting methodologies to applying advanced techniques for complex issues. As you move forward, revisit any topics as needed to reinforce your understanding and ensure you're prepared for the final assessment. Good luck and congratulations again on reaching this important milestone in your learning journey.
On a typical workday, your inbox pings frequently. Tickets are raised using Teams, Slack, and emails, and workers passing by your office manually log them. You must address a range of issues, such as operating system error messages, analyzing logs, and installing various software. You must also remotely access employee computers to install updates, troubleshoot issues, and configure a productive environment. You desperately need IT support and ideas to simplify planning so you can gain some more time in the day. Requests for your time are frequent, and you often do not have the time to properly research the technology you are using. What can you do? In this video, you'll explore how you can use Microsoft Copilot to help troubleshoot common IT problems. It acts as a companion that provides up-to-date information and is capable of troubleshooting log issues. It also guides your problem-solving methodology by providing tips and insights. By the end of this lesson, you will be aware of the benefits of using Microsoft Copilot in Bing, but also understand that the results it provides should only be used to guide research rather than accepted without question. Let's begin by examining the core capabilities and features of Microsoft Copilot in Bing and some practical applications. Firstly, there's instant troubleshooting. Microsoft Copilot in Bing is a large language model, or LLM, trained on manuals and online forums. Think of it like a powerful search engine. You enter a prompt detailing your issue in natural language, and Microsoft Copilot in Bing taps into its vast knowledge base to offer solutions, workarounds, and best practices. Next, there's script automation. With Microsoft Copilot in Bing, you can automate repetitive tasks such as password resets, software installations, and user account management. While Microsoft Copilot in Bing does not automate the task itself, when you give it a prompt that details the technology, task, and required solution format, it generates custom scripts tailored to your specific needs. This saves you valuable time and minimizes errors. And finally, there's proactive support. Microsoft Copilot in Bing can analyze system logs, network traffic, and user behavior patterns to identify potential problems before they escalate. This enables you to address issues preemptively, reducing downtime and ensuring a smooth user experience. In addition to these core capabilities and features, you can also use Microsoft Copilot in Bing for training purposes. Imagine a scenario where your company network has experienced a cyber attack, attempting to breach the network. While the attack was not successful, it demonstrated that malicious actors were attempting to disrupt the daily operations of the company. Your boss raises a ticket with you asking what measures can be taken to counteract future attacks. Here's where Copilot can help. First, you can create a prompt that details the nature of your business, providing some essential details that can inform the answer. Next, you can use Microsoft Copilot in Bing to research common attacks that may occur on your network. This research can detail different types of attacks, how and why they are carried out, as well as providing some solutions. While Microsoft Copilot in Bing does not implement the changes, it can help you craft a detailed response to implement. Remember, once you have the technical details, it is important that you verify the information from reputable sources. You can then enter a prompt asking for instructions on the measures you have decided to implement. After you have compiled an area of research and further verified the information, you can also use Microsoft Copilot in Bing to help educate staff, for example, on best practices when using their work computers. Copilot not only has the ability to generate text, it can also analyze and generate images. When creating your prompt, you can first outline how best to convey the important concepts in a language that can be easily understood and remembered by both technical and non-technical staff. Next, you can create a prompt that generates images and diagrams that can be put around the office with helpful tips and insights. In this video, you have gained an understanding of how you can apply Microsoft Copilot in Bing to help you in your everyday tasks. You explored its core features and capabilities and how you can use it to become more proficient at your job. It's a valuable research assistant that can create the outline of a strategy. You also learned that it uses generic sources such as online forums, and while the information may appear accurate, you should always validate the results it generates before implementing any actions. Making changes in a business setup can be challenging. You have to make decisions based on cost, use, accessibility, usability, and the company's skill set. Generative AI can be a very useful tool in assisting you to quickly conceptualize a business need. The fundamental need here is to learn to craft effective prompts to get the output you need in the way that you need it. In this video, you'll learn how to create prompts that can vary in technical complexity depending on how they are phrased. You'll also explore the Role Task Context Output, or RTCO framework, and the importance of assigning a role when creating a prompt to generate an answer that best meets your needs. Let's start by gaining a better understanding of the tools you can use. The first thing to consider when creating accurate prompts is the generative AI model you use. What is it and how is it built? Earlier, you learned that this model is an example of natural language processing, or NLP, and that it uses algorithms and statistics to find patterns in natural language. Put simply, it is about modeling the language that you use to extract meaning. As humans, we are naturally built to process languages. They have evolved with us over time, and as our society changes, new words are developed to express these concepts. Words can change meaning, and we can have many words with the same meaning. One word can also have many meanings. In your brain, the synapses fire from signals received from your 6 senses. These trigger electrical impulses to activate various brain nodes, resulting in your thoughts and memories. Generative AI is designed to work in the same fashion. When you enter text or images into the prompt, it passes these through its own specially designed nodes, much like our synapses, and generates an output. With this understanding, let's explore how best to create prompts. The RTCO framework is an approach designed to help you frame your prompts. It's focused on 4 integral ideas that can help you create strong, effective prompts. You can generate prompts quickly and effectively by breaking them down into the 4 key areas of role, task, context, and output. Remember, generative AI models are trained from scraping information found everywhere on the web. This includes news sites, YouTube comments, scientific papers, and social media chat forums. The ideas found there are expressed in a myriad of different ways. Some are formal, some are informal, and others are very detailed and technical. Some ideas overlap or use similar terminology, but with wildly different intents. So when you are creating a prompt, think about it like orienteering. You have a map, a compass, a pair of good sturdy boots, and a keen interest in visiting nature. First, let's define the role you want the AI to take on. Consider the following prompt. You are an intrepid hiker set on tackling long and enduring treks. What equipment will you pack? And here is the generated output. Some of the suggestions are geared toward a long and strenuous hike, including thick, heavy clothing, a large amount of water and food, and a first aid kit. Now let's alter the role a little. Let's say that you are an aging hiker also interested in tackling a long and enduring trek. How does the change of role alter the result? Let's reword the prompt like this. You are an elderly hiker set on tackling long and enduring treks. What equipment will you pack? Notice that the same prompt with a different role focuses on different aspects, even in the introductory brief. While the initial response detailed the requirements for a safe and successful trip, this second prompt outlined an extra feature of comfort and making the experience enjoyable. This reflects an understanding that the language model has the role of being an intrepid rather than an elderly hiker. Other noticeable features include a greater emphasis on bringing suitable clothing, trekking poles, a wide-brimmed hat for sun protection, and an emergency whistle. Things an intrepid hiker might not necessarily need. To better understand the idea of a role in the context of an IT support specialist, let's examine changing the role in the prompt and how it affects the output. Let's input the following prompt. You are a technically gifted software engineer explaining the concept of NLP. Output a concise paragraph. You'll notice that the output includes technical terms listed in a formatted way and highlights their importance with definitions that assume an understanding from the audience. Now, let's highlight how Copilot interprets and responds if the query is run with one slight adjustment, altering the role from a technically gifted engineer to a child. The prompt might look like this. You are a child explaining the concept of NLP. Output a concise paragraph. Notice the output is very different. The language model has made a distinction between the needs of an engineer in searching for NLP and those of a child. NLP has been linked with neuro-linguistic programming in place of our intended natural language processing. Also, notice the language used in the output. While the initial response was loaded with technical terms, this output focuses on simplistic, non-technical definitions, explaining the concepts rather than the technical background. It's important to remember that generative AI is not deterministic, meaning you don't always get the same responses from queries. There is a big difference in how the model processes the prompt, which underlines the importance of getting the role right. In this video, you learned the secrets to crafting effective prompts with generative AI by mastering the RTCO framework. By understanding how to assign roles, you've seen firsthand how even subtle changes can lead to vastly different and more targeted outputs. From intrepid hikers to IT specialists, the role you choose can transform your prompt and tailor the response to fit your exact needs. You also learned that generative AI is not deterministic, so when you enter the same prompt at different times, you will get different responses. Whether you're tackling business challenges or exploring new ideas, generative AI is here to assist you every step of the way. Early one Monday morning, you sit at your workstation, and after you log in with your credentials, you are met with a flurry of emails. Some emails are urgent and demand immediate attention, while others have vague subject lines and attachments that raise red flags. However, some staff members still entertain such emails by clicking on the embedded links. You've gone to great lengths to educate the staff on the best practices and what you define as good cyber hygiene, but it appears that there is still a gap that must be bridged and, therefore, much work to do. In this video, you'll gain insight into some good cyber hygiene practices and learn how Microsoft Copilot can help you not only outline these best practices, but also create material that you can use to educate staff. Let's kick things off by examining cyber hygiene in more detail. Cyber hygiene refers to the fundamental practices and habits individuals and organizations use to maintain the health and security of their digital systems and data. Just like personal hygiene helps prevent the spread of disease, cyber hygiene safeguards against cyber threats. Implementing strong password management, regularly updating software and systems, using antivirus and firewalls, and educating employees about phishing and social engineering attacks are crucial components of good cyber hygiene. These practices build multiple layers of defense, making it much harder for cybercriminals to find weaknesses and gain access to data. By prioritizing cyber hygiene, organizations can minimize the risk of data breaches, malware infections, and other malicious activities, protecting their reputation, financial assets, and sensitive information. To better understand this concept, let's examine a real-world use case for generative AI, the cyber threat of phishing attacks. Through emails, texts, or websites, cybercriminals deceptively disguise themselves as trustworthy individuals in a phishing attack. They try to trick individuals into revealing sensitive information like passwords, credit card numbers, or personal data. Like a fisherman luring a fish with bait, they craft enticing messages, creating a sense of urgency or curiosity. They use this method to manipulate victims into clicking malicious links or downloading malware. By prioritizing cyber hygiene and remaining vigilant against these tactics, individuals and organizations can protect themselves from phishing scams and safeguard their valuable information. With this in mind, you turn to Microsoft Copilot in Bing and enter a prompt asking to outline some best practices. It generates some output containing some very useful advice, such as use unique, complex passwords for each account and consider a password manager. Update software, operating systems, and applications regularly using hot and cold patches when required. Install reputable security software and keep it updated. Avoid clicking on suspicious links or opening unexpected attachments, including links that may be shortened to hide the true destination. Be skeptical of unsolicited emails or messages asking for personal information. Back up important data to an external source regularly. Enable two-factor authentication or 2FA wherever possible for added security. And finally, educate yourself and your employees about cyber threats and best practices. Taking the final suggestion, you create another prompt with the appropriate role, task, context, and output, asking how you can better educate staff. One suggestion is to create educational material and post it around the office. Let's demonstrate how you can input a prompt in Microsoft Copilot in Bing to generate some images that you could use to achieve this goal. First, using your Microsoft Edge web browser, navigate to the Copilot homepage and click Sign In at the top of the screen. In the Ask Me Anything text box, create a prompt assigning a role, in this case an IT support specialist, followed by a task, creating learning material for the office, then the context, best practices to avoid phishing in a work-related environment, and finally the output, generated images. Your prompt might look like this. You are an IT support specialist creating learning material for the office. In particular, you are interested in outputting educational sheets that advise staff on best practices to avoid phishing attempts when using work computers. Output this informative image with instructional design of the do's and don'ts when engaged with work activities. Select the image you want to use and click Download. In this demonstration, you learned how you can use Microsoft Copilot in Bing to create images to inform your colleagues on some best practices to avoid being phished. It's important to note that prompts don't have to be exact. Remember, you want to provide Microsoft Copilot in Bing with 4 key items: the role, task, context, and output. Ordinary language parameters such as spelling and grammar are less important when making prompts because Microsoft Copilot in Bing has sufficient data to reason out the intended meaning even if a word is misspelled. It does this using context and guessing the correct intent. It is important to note that this is always an iterative process, meaning that you will try several variations of the prompt before you get the output that you are looking for. Recall the image in the demonstration earlier. It had spelling errors in the text, so some manual editing may be required before you can use the image. As with other examples of Microsoft Copilot in Bing, it's best to consider it an assistant that aids you in your task, but it cannot replace human input and verification. In this video, you learned about maintaining strong cyber hygiene and how to use Microsoft Copilot in Bing to provide you with some best practices and educate your colleagues. You also gained an understanding of how to create educational materials with generative AI, highlighting the importance of well-crafted prompts. Remember, while tools like Microsoft Copilot in Bing can help you to create training materials, they still benefit from a human touch for accuracy and effectiveness. By combining these AI-generated resources with your expertise, you can better safeguard your workplace against cyber threats. By now, you are familiar with an effective framework for creating efficient prompts. This involves reformulating your prompt into 4 distinct components: role, task, context, and output. In this video, you'll apply this knowledge to a real-world business scenario, showcasing the power of Microsoft Copilot to enhance workflows. You will also explore services that might be useful for a startup business looking to build an open and collaborative working environment. Let's begin by examining a scenario where you are part of a startup specializing in digital marketing solutions. You want to expand through recruitment of skilled remote employees spread across different time zones. The goal of this expansion is to facilitate the creation of a collaborative, efficient, and communicative work environment. However, you are currently relying on unconnected tools and platforms, leading to challenges for project management, communication, and document sharing. You seek a comprehensive suite of integrated solutions that can streamline workflows, enhance collaboration, and support your remote workforce. This is where Microsoft Copilot's AI capabilities come in to meet your needs. So, let's create effective prompts by applying the Role, Task, Context, Outcome, or RTCO framework. For the role, start by defining it as a specialist Microsoft consultant. This role empowers Microsoft Copilot in Bing to think from the perspective of someone who understands sales processes and can leverage Microsoft tools to improve them. Next, the task is to output a list of Microsoft services. You'll then provide Microsoft Copilot in Bing with detailed context about the current workflow. A startup business looking to hire remote workers and create a collaborative environment. And finally, you'll specify the format and type of output you want from Microsoft Copilot in Bing. For research, it is important to have a readable listed set of services, as well as a link that can be followed for more information on these services. Now let's walk through these steps using the Microsoft Copilot in Bing interface. The first step is to formulate the prompt. Create a clear and concise prompt incorporating the role, task, context, and output details. It might look like this. You are a specialist Microsoft consultant. You have been hired by a startup to identify a list of potential services that can help drive their business. The startup aims to hire remote workers who will collaborate in a dynamic environment. Output a list of Microsoft services with links. In the generated output, Microsoft Copilot in Bing identifies the available technologies and where they can be applied. Next, you need to refine the query to identify the tools. You can do this by expanding your query by interrogating the initial list for more information, like this. For each of the services listed, provide pricing and a link to verify this information attached to the price. Finally, you can analyze the results by carefully reviewing Microsoft Copilot in Bing's recommendations and selecting each of the clickable links. In the demonstration, you saw how the query took the initial prompt and returned a list of Microsoft-based services as directed. Teams, OneDrive, and SharePoint all meet the brief that you required expanding upon. Put simply, Microsoft Copilot for Bing extrapolated that your business requires a platform to help employees interact with each other, a storage location for your work, and a globally accessible space for editing documents. You expanded on the query, looking for some actionable insights on the output. For the first link, you were directed to a generic Teams location. Although it didn't include the pricing information you requested, it did provide information on Teams. The second link accurately took you to SharePoint pricing, and the third link also presented some accurate Microsoft 365 pricing, though it omitted to include the reference to the free plan. When you use Microsoft Copilot in Bing as an assistant to help you gather facts, it's important to verify all the information it returns. In a more in-depth fact-finding approach, you would list the pros and cons of each service, ask for alternatives, and generally use it to drill into the data and help direct your research. When you do this, your previous prompt is saved and it's added as context to your next query. This is done to aid Microsoft Copilot in Bing in identifying what you require. Finally, you can change your prompt with the keyword regenerate. This takes the previous prompt and reruns it with whatever update you instructed within the regenerate prompt. For example, you might decide you don't want a list, but instead a paragraph with descriptions throughout. You could input regenerate as a concise paragraph, include summary information on each link. This can be a helpful keyword when reformulating your queries. In this video, you gained an understanding of how the RTCO framework empowers you to leverage Microsoft Copilot in Bing for real-world business scenarios. By carefully crafting your prompts, you can speed up your research into creating a practical working environment for your team. You also learned that even though the information returned has a degree of accuracy that makes it very useful, it still requires a human touch to verify it. Finally, you learned that context is taken from your previous prompts to better direct the learning. It's time for you to dive in and see how these tools can transform your productivity and collaboration.
Congratulations! You've shown remarkable dedication and effort and made it to the end of the course. You've mastered crucial skills and concepts related to technical diagnostics and troubleshooting techniques, demonstrating that you have what it takes to troubleshoot and resolve an array of hardware, software, and system-related IT issues. You are now able to apply a systematic approach to diagnose technical issues across different environments using different tools and techniques. By completing this course, you have a good grasp of the fundamentals of diagnostics and troubleshooting, including foundational concepts, problem-solving strategies and models, as well as common hardware and software issues. But that's not all. You've also gained valuable insight into tools for troubleshooting across different operating systems like Windows, Mac OS, and Linux, and how to troubleshoot system-related and cross-platform problems. And let's not forget advanced troubleshooting. You now know the techniques and skills for resolving complex and rare issues. Additionally, you learned how to use diagnostic tools and utilities and troubleshoot network-related scenarios. And you applied what you learned by analyzing and interpreting multiple diagnostic outputs related to a complex network issue to identify the root cause and possible solutions while documenting the whole process. Think about everything you can do with this newfound knowledge and skills. You have now successfully completed all of the courses in the Microsoft IT Support Specialist program, which means that you will receive a professional Coursera certification. The certification is recognized globally, so it enhances your credibility and marketability to potential employers. It serves as proof of your job readiness and can be shared with your professional network. And it demonstrates your commitment to continuous learning and professional development. The certification can benefit you if you are seeking an entry-level position in IT, so well done on taking the first steps towards your future career. Completing the program also serves as an essential stepping stone in your preparation for the Microsoft MS900 exam. Passing this exam will earn you the Microsoft 365 Fundamental Certification. This certification requires you to demonstrate foundational knowledge of Microsoft 365 services, including cloud concepts, security, compliance, and collaboration tools. Achieving the Microsoft 365 Fundamental Certification validates your understanding of essential concepts in cloud-based productivity and collaborative solutions. To complete the exam, you should be able to recommend Microsoft 365 solutions that address common organizational IT challenges. And you should understand how Microsoft 365 solutions improve productivity, facilitate collaboration, optimize communications, help secure data, and identify and facilitate compliance. In summary, this course has enhanced your knowledge and skills in diagnostics and troubleshooting and helped you prepare for the MS900 exam. It takes perseverance to complete a whole program, and you've done a great job so far. You should be proud of your progress and achievement. The experience you gained will show potential employers that you're motivated, capable, and not afraid to learn new things. But what comes next? While this marks the end of the course, it should not be the end of your learning journey. You can continue honing your skills and knowledge by registering for one of Coursera's other Microsoft programs. Thank you for your hard work and good luck with the rest of your learning journey.